Hello tech enthusiast, welcome to an exciting journey into the realm of DevOps. You are tuned into Simplilearn's YouTube channel, your go-to destination for cutting-edge tech education. In this full course for 2024, we will delve into DevOps principles, automation, containerization and more. Whether you're a beginner or a seasoned professional, this course is tailored to equip you with the latest skills ready to stay ahead in the dynamic world of software development and IT operations. Hit that subscribe button, give this video a thumbs up, and let's embark on the DevOps adventure together.
If you want to upskill yourself, master DevOps skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various DevOps programs. Simplilearn offers various certification and postgraduate programs in collaboration with some of the world's leading universities like Caltech and Google Cloud. Through our courses, you will gain knowledge and work-ready expertise in skills like DevOps methodology, deployment automation, CI/CD pipeline, and over a dozen others. That's not all. You will also get the opportunity to work on multiple projects and learn from industry experts working in top-tier product companies and academians from top universities. After completing these courses, thousands of learners have transitioned into DevOps role as a fresher or moved on to a higher-paying job role and profile. So if you are passionate about making your career in this field, then make sure to check out the link in the pinned comments and description box to find DevOps program that fits your expertise and areas of interest.
And today we're going to go through and introduce you to DevOps. We're going to go through a number of key elements today. The first two will be reviewing models that you're already probably using for delivering solutions into your company. And the most popular one is waterfall, followed by agile. Then we'll look at DevOps and how DevOps differs from the two models and how it also borrows and leverages the best of those models. We'll go through each of the phases that are used in typical DevOps delivery, and then the tools used within those phases to really improve the efficiencies within DevOps. Finally, we'll summarize the advantages that DevOps brings to you and your teams. So let's go through waterfall. So waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile. And we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products, and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers, but what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the agile model. The agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit, is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another pointer here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment so you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to the all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages. And there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams, so teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted.
Welcome to the ultimate guide to the future of tech. In the fast-paced world of DevOps, staying ahead is the game changer. Join us as we unlock the top DevOps skills needed in 2024. From mastering cloud architectures to building security fortresses, we are delving into the vital skills shaping the tech landscape. Get ready to unravel the roadmap to DevOps success and set your sights on the tech horizon. Let's get started. Number 1. Continuous integration and continuous deployment, CI/CD. CI/CD, the backbone of modern software delivery, makes integrating code changes and deploying them smooth and fast. Tools like Jenkins and GitLab take care of testing, version control, and deployment, cutting down manual work. Learning these tools might take a bit of time, focusing on version control, scripting, and how systems run. To get better at CI/CD, trying hands-on projects like setting up pipelines for web apps or automating testing can be a game changer. Number 2. Cloud architecture and Kubernetes. Knowing about cloud architecture and mastering Kubernetes is a big deal today. Companies are all about cloud services and using Kubernetes to manage apps stored in containers. Learning these involves understanding various cloud services and how to use them to build strong and flexible applications. It also means knowing how to set up and manage containers in the cloud environment. Getting good at this might take some effort, especially learning about networks, containers, and cloud computing. Hands-on practice like deploying small apps with Kubernetes or automating deployments can be a solid way to level up. Number 3. Infrastructure as Code, IAC with Terraform. Terraform is a star in managing infrastructure by writing scripts. It helps set up and manage things like servers or databases without manual configurations. Mastering it means understanding Terraform's language and managing resources across different cloud providers. Getting good at Terraform might not be too hard if you get the basics of cloud architecture. Doing projects like automating cloud setups or managing resources across different cloud platforms can boost your skills in this area. Number 4. Security automation and DevSecOps. Keeping systems secure is top priority, and that's where DevSecOps shines. It's about integrating security into every step of the development process. This needs understanding security principles, spotting threats, and using tools within the development cycle to stay secure. Getting skilled at this might take some time, focusing on security practices and how they fit into development. Trying out projects like setting up security checks in your development process or making sure apps are encrypted can sharpen these skills. Number 5. Data Ops and AI/ML integration. Data Ops mixed with AI and ML is the new thing for smarter decision making. It's about making data-related work smooth and automated and then mixing that data with AI and ML to make awesome decisions. Learning this might need digging into data processing, machine learning, and programming languages like Python, R, or Scala. Projects like building models or setting up data pipelines can give hands-on experience in this fusion of data and smart tech. Number 6. Monitoring and observability tools. Monitoring tools keep systems healthy by finding problems before they cause trouble. Tools like Prometheus or Grafana help keep an eye on system performance and solve issues quickly. Learning these tools might need some time, especially getting used to metrics and logs. Projects like setting up performance dashboards or digging into system logs can really polish these skills. Number 7. Microservices architecture. Breaking down big applications into smaller parts is what microservices are about. It helps in better scalability and flexibility. Getting good at this might take a bit of understanding how these smaller parts talk to each other and using languages like Java or Python. Trying projects like breaking down big apps or putting these small services into containers can make you a microservices pro. Number 8. Containerization beyond Kubernetes. Beyond Kubernetes, there are other cool tools like Docker or Podman that help manage containers, making life easier. Learning these tools might need a basic understanding of system administration and containers. Working on projects like creating custom container images or managing multi-container apps can really amp up your container game. Number 9. Serverless computing and FaaS. Serverless platforms like AWS Lambda or Azure Functions let developers focus on writing code without handling the backend stuff. Mastering this might need getting familiar with serverless architecture and programming in languages like Node.js, Python, or Java. Doing projects like building serverless apps or automating tasks with serverless functions can level up your serverless skills. Number 10. Collaboration and soft skills. Apart from the tech stuff, being a team player and communicating well is super important. Working on open source projects or joining diverse teams can really boost these skills. Projects like leading teams through DevOps changes or driving cultural shifts in an organization can improve these skills in a big way. Before we conclude this exhilarating expedition into the top 10 DevOps skills for 2024, envision this. The future is a canvas waiting for your innovation and expertise to paint upon. These skills aren't just a checklist, they are your toolkit for crafting the technological future. Embrace them, immerse yourself in their practice, and let them be the fuel propelling your journey toward mastery. In this rapid evolving tech realm, remember, it's not just about knowing, it's about doing. Dive into project experiments fearlessly and let these skills be the guiding stars illuminating your path to success. Thank you for joining us on this adventure. Make sure to like this video and share it with your friends. Do check out the link in the description and pinned comment if you are interested in making a career in DevOps.
Welcome to Simplilearn. Starting on the AWS DevOps journey is like getting sail on a high-tech adventure. In this tutorial, we'll be your navigators through the vast seas of Amazon Web Services, helping you to harness the power of DevOps to streamline your software delivery and infrastructure management. From understanding DevOps principles to mastering AWS services, we will guide you through the transformative voyage. Whether you're a seasoned sailor or a novice explorer, our roadmap will unveil the treasures of continuous integration, containerization, automation, and beyond. So, hoist the DevOps flag and get ready to chart a course towards efficiency, collaboration, and innovation in the AWS ecosystem. That said, if these are the type of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified. So, without further delay, let's get started with the agenda for today's session. First, we will understand who exactly is an AWS DevOps engineer, then the skills required to become an AWS DevOps engineer, followed by that the important roles and responsibilities, and now the most important point of today's session, that is the roadmap or how to become an AWS DevOps engineer. Followed by that, we will also discuss the salary compensation being offered to a professional AWS DevOps engineer. And lastly, we will discuss the important companies hiring AWS DevOps engineers. So I hope I made myself clear with the agenda. Now let's get started with the first subheading, that is, who exactly is an AWS DevOps engineer? The answer for this question is, an AWS DevOps engineer is a professional who combines expertise in AWS, that is Amazon Web Services, with the DevOps principles to streamline software development and infrastructure management. They design, implement, and maintain cloud-based solutions leveraging AWS services like EC2, S3, and RDS. DevOps engineers automate processes using tools such as AWS CloudFormation and facilitate continuous integration and deployment pipelines. Their role focuses on improving collaboration between development and operations teams, ensuring efficient, reliable, and secure software delivery. With skills in infrastructure such as IAC or infrastructure as code, containerization, scripting, and continuous integration, AWS DevOps engineers play a critical role in optimizing cloud-based applications and services. And that's exactly an AWS DevOps engineer. Now moving ahead, we will discuss the important skills required to become an AWS DevOps engineer. The role of an AWS DevOps engineer requires a combination of technical and non-technical skills. Here are the top 5 skills that are crucial for an AWS DevOps engineer. Starting with the first one, AWS expertise. Proficiency in AWS is fundamental. DevOps engineers should have a deep understanding of AWS services including EC2, S3, RDS, VPC, and much more. They should be able to design, implement, and manage cloud infrastructure efficiently. The next one is IAC or infrastructure as code. IAC tools like AWS CloudFormation or Terraform are essential for automating the provisioning and management of infrastructure. DevOps engineers should be skilled in writing infrastructure code and templates to maintain consistency and reliability. Third one is scripting and programming. Knowledge of scripting languages, example Python, Bash, and programming languages is important for automation and custom scripting. Python in particular is widely used for tasks like creating deployment scripts, automating AWS tasks, and developing custom solutions. Next one is containerization and orchestration. Skills in containerization technologies such as Docker and container orchestration platforms like Amazon ECS or Amazon EKS are vital. DevOps engineers should be able to build, deploy, and manage containerized applications. Now the fifth one is CI/CD pipelines or continuous integration and continuous deployment. Proficiency in setting up and maintaining CI/CD pipelines using tools like AWS Code Pipeline, Jenkins, or GitHub CI/CD is crucial. DevOps engineers should understand the principles of automated testing, integration, and continuous deployment to streamline software delivery. Effective communication and collaboration skills are essential, as DevOps engineers work closely with DevOps development and operations teams to bridge the gap between them and ensure smooth software delivery and infrastructure management. Problem-solving skills, the ability to troubleshoot issues, and a strong understanding of security best practices are also important for this role. DevOps engineers need to be adaptable and keep up with the evolving AWS ecosystem and DevOps practices to remain effective in their role. Moving ahead, we will discuss the roles and responsibilities of an AWS DevOps engineer. The roles and responsibilities of an AWS DevOps engineer typically revolve around managing and optimizing the infrastructure and development pipelines to ensure efficient, reliable, and scalable operations. Here are the top 5 roles and responsibilities of an AWS DevOps engineer. Starting with the first one, that is IAC management. DevOps engineers are responsible for defining and managing infrastructure using IAC tools like AWS CloudFormation or Terraform. They create and maintain templates to provision and configure AWS resources, ensuring consistency and repeatability. Next one is continuous integration and deployment. Continuous integration and continuous deployment, or also known as CI/CD, is very critical. DevOps engineers establish and maintain CI/CD pipelines, automating the build, test, and deployment processes. They use AWS Code Pipeline, Jenkins, or similar tools to streamline the delivery of software and updates to production environment. Next is server and containerization management. DevOps engineers work with AWS EC2 instances, ECS, EKS, and other services to manage servers and containers. They monitor resource utilization, configure auto-scaling, and ensure high availability and fault tolerance. Managing and logging is the fourth one. Monitoring is a critical responsibility. DevOps engineers set up monitoring and alerting systems using AWS CloudWatch, analyze logs, and respond to incidents promptly. They aim to maintain high system availability and performance. Security and compliance is the fifth one. So security is a priority. DevOps engineers implement and maintain security best practices, manage AWS identity and access management, that is IAM policies, and ensure compliance with regulatory requirements. They often work with AWS services like AWS Security Hub and AWS Config to assess and improve security. AWS DevOps engineers are involved in optimizing costs, ensuring disaster recovery and backup strategies, and collaborating with development and operations teams to enhance communication and collaboration. They may also assist in automating routine tasks and prompting a culture of continuous improvement and innovation within the organization. Now, the most important aspect of today's session, that is how to become, or the roadmap to become, an AWS DevOps engineer. The AWS DevOps roadmap provides a high-level guide for individuals or teams looking to adopt DevOps practices in the context of Amazon Web Services. DevOps is a set of practices that combine software development, dev, and IT operations, ops, to enhance collaboration and automate the process of software delivery and infrastructure management. AWS offers a range of services and tools to support AWS practices. Here is a roadmap to help you get started with AWS and DevOps. Creating a roadmap for AWS DevOps in 10 steps can help you guide your journey towards implementing DevOps practices on the Amazon Web Services platform. The first one is understand DevOps principles. Start by gaining a solid understanding of DevOps principles and practices. DevOps is about collaboration between development and operations team to automate and streamline the software delivery process. Second one is learn AWS fundamentals. Get acquainted with AWS services and understand the basics of cloud computing, including compute, storage, and networking services. AWS offers a wide range of services that can be leveraged in your DevOps processes. Third one is set up your AWS account. Sign up for an AWS account and configure billing and security settings. You may also want to consider using AWS organizations for managing multiple accounts and AWS identity and access management for user access control. Fourth step is source code management. Implement source code management using a tool like Git and host your code repositories on a platform like AWS Code Commit or GitHub. Learn about version control best practices. The fifth step is continuous integration. Set up a CI/CD pipeline using services like AWS Code Pipeline, AWS Code Build, or Jenkins. Automate building, testing, and deployment of your code. Sixth one being infrastructure as code, or IAC. Embrace IAC principles to manage your AWS resources. Use tools like AWS CloudFormation, Terraform, or AWS CDK to define and provision infrastructure as code. Seventh step being deployment and orchestration. Use AWS services like AWS Elastic Beanstalk, AWS Elastic Container Service, or ECS, or Kubernetes on AWS, also known as EKS, for deploying and managing your applications. Orchestrate these deployments using AWS step functions or other automation tools. Now the eighth step is monitoring and logging. Implement robust monitoring and logging services using services like Amazon CloudWatch and AWS CloudTrail. Create dashboards, set up alarms, and analyze logs to gain insights into your application's performance and security. Now the ninth one, security and compliance. Focus on security by following AWS best practices using AWS Identity and Access Management IAM effectively, and automating security checks for AWS Config and AWS Security Hub. Ensure your infrastructure and applications are compliant with industry standards. Now, the last, continuous learning and improvement. DevOps is an ongoing journey of improvement. Continuously monitor and optimize your DevOps pipeline, incorporate feedback, and stay updated on new AWS services and best practices. Ensure a culture of learning and innovation within your team. Remember that this roadmap is a high-level guide, and the specific tools and services you choose may vary based on your project's requirements. DevOps is your culture of collaboration and automation, so adapt your DevOps practice to best suit your team's needs and the AWS services that you use. Now, moving ahead, we will discuss the salary compensations being offered to an AWS DevOps engineer. Now, if you are in India and a beginner in AWS DevOps domain, you can expect salaries ranging from 3 lakhs to 6 lakhs per annum. If you're an intermediate candidate with minimum 2 years of experience, then you can expect salaries ranging from 6 lakhs to 12 lakhs per annum. If you are an experienced candidate with more than 4 years of experience, the minimum salary you can expect is 12 lakhs, and it can go all the way up to 20 or more based on the project you're working with, company you're working with, and the location. Now, if you are in America and if you are a beginner in AWS DevOps domain, then you can expect an average salary of $80,000 to $120,000 per annum. And if you are an intermediate candidate with minimum 2 years of experience, then you can expect salaries ranging from $120,000 to $150,000 per annum. If you are a highly experienced candidate, maybe with 4 or more than that, you can expect salaries ranging from $150,000 to $200,000 per annum. And again, it might also go up based on the project you're working with, based on the company you're working with, and in the location. Now, moving ahead, we will discuss the next important and also the last important topic of today's discussion, that is the companies hiring AWS DevOps engineers. There are a lot of companies hiring AWS DevOps engineers, but the prominent players in this particular field is Amazon Web Services, Google, Microsoft, IBM, Oracle, Netflix, Adobe, Cisco, Slack, Salesforce, Deloitte, and much more.
Talking about the salary figures of a senior DevOps engineer, according to Glassdoor, a senior DevOps engineer working in the United States earns a whopping salary of $178,362. The same senior DevOps engineer in India earns 18 lakh rupees annually. To sum it up, as you progress from entry level to mid-level and eventually to experienced DevOps engineer, your roles and responsibilities evolve significantly. Each level presents unique challenges and opportunities for growth, all contributing to your journey as a successful DevOps professional. So excited about the opportunities DevOps offers? Great. Now let's talk about the skills you will need to become a successful DevOps engineer. Coding and scripting. Strong knowledge of programming languages like Python, Ruby, or JavaScript and scripting skills are essential for automation and tool development. System administration. Familiarity with Linux, Unix, and Windows systems, including configuration and troubleshooting. Cloud computing. Proficiency in cloud platforms like AWS, Azure, or Google Cloud to deploy and manage applications in the cloud. Containerization and orchestration. Understanding container technologies like Docker and container orchestration tools like Kubernetes is a must. Continuous integration or deployment. Experience with CI/CD tools such as Jenkins, GitLab CI, or Circle CI to automate the development workflow. Infrastructure as code. Knowledge of IAC tools like Terraform or Ansible to manage infrastructure programmatically. Monitoring and logging. Familiarity with monitoring tools like Prometheus, Grafana, and logging solutions like ELK Stack. Acquiring these skills will not only make you a valuable DevOps engineer, but will also open doors to exciting job opportunities. So to enroll in the postgraduate program in DevOps today, click the link mentioned in the description box below. Don't miss this fantastic opportunity to invest in your future. So let's take a minute to hear it out from our learners who have experienced massive success in their career through a postgraduate program in DevOps.
So what are we going to cover today? So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run in is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code code changes you made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git client to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, is actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public shareable. Is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way, way, way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merge into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means though is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. And you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it can be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here, and then here we have a separate parallel branch which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch. And we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's being done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So Git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. It makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. The good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the git command, commits changes to head up. So the git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config - global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author of by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you can then merge that into the main branch. A Git rebase will reapply commits on top of another base tip. And Git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we'll actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window, and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the README file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into README file, and I can change this. So we can go hello Git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the README text. So to do that, we'll use the diff command for Git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world, and then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. And so what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and select git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn -GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello-world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https github.com/simplylearn-github, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote add origin, and we'll connect to the remote location github.com/simplylearn-hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project because I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in. And we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature. And then we can then paste in the URL of the new directory that has the forked work in it. And now at this point, we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch, and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub, and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name, or by email address, or by their full name. One of the things that you want to be able to do is ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder I call it test, and we're going to move into the test folder, and we will initialize that folder. And we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2. And now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit. And it's gone ahead and added those files. And so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. You call this one git branch test _ branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test _ branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test _ branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test _ branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modify. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we've seen it's the text-free change that was made. And we can now go through the process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a. And we're going to commit those files. Git commit -a -m, adding 2 new files. And it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master. So we do git rebase master, and that will then give us the command that everything is now completely up to date. And we can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list, and there we have all of our files listed in correctly.
If we talk in the literal sense, Maven means accumulator of knowledge. Maven is a very powerful project management tool, or we can call it a build tool, that helps building, documenting, and managing a project. But before we move forward and dive deep into the basics of Maven, let's understand what is meant by the term build tool. A build tool takes care of everything for building a project. It generates a source code, generates documentation from a source code, it even compiles the source code and packages the compiled codes into jar of zip files. Along with that, the build tool also installs the packaged code in local repository, server repository, or central repository. Coming back to Maven, it is written in Java or C#, and it is based on Project Object Model or POM. Again, let's have a pause and understand what is meant by this term Project Object Model. A Project Object Model or POM is a building block in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build a project. This file resides in the base directory of the project as pom.xml file. The POM contains information about the project and various configuration details. It also includes the goals and plugins used by Maven in a project. Maven looks for the POM in the current directory while executing a task or a goal. It reads the POM, gets the needed configuration information, and then runs the goal. Coming back, Maven is used to building and managing any Java-based project. It simplifies the day-to-day work of Java developers and helps them in their projects. Now, when we know the basics of Maven, let's have a look at some reasons to know why is Maven so popular and why are we even talking about it. So, let's have a look at the need for Maven. Maven, as by now we know, is popularly used for Java-based projects. It helps in downloading libraries or jar files used in the project. To understand the part of why do we use Maven or the need of Maven, let's have a look at some problems that Maven solved. The first problem is getting the jar files. In a project, getting the right jar files is a difficult task, where there could be conflicts in the versions of the two separate packages. However, it makes sure all the jar files are present in its repositories and avoid any such conflicting scenarios. The next problem it sorted was downloading dependencies. We needed to visit the official website of different software, which could be a tedious task. Now, instead of visiting individual websites, we could visit mvnrepository.com, which is a central repository of the jar files. Then Maven plays a vital role in the creation of the right project structure in servlets, struts, etc. Otherwise, it won't be executed. Then Maven also helps to build and deploy the project so that it may work properly. So the next point is what exactly Maven does. It makes the building of the project easy. The task of downloading the dependencies and jar files that were to be done manually can now be done automatically. All the information that is required to build the project is readily available now. Finally, Maven helps manage all the processes such as building, documenting, releasing, and other methods that play an integral part in managing a project. Now, when we know everything about Maven, let's look at some companies that use Maven. There are over 2,000 companies that use Maven today. The companies that use Maven are mostly located in the United States and in the computer science industry. Maven is also used in industries other than computer science, like information technology and services, financial service, banking, hospital and care, and much more. Some of the biggest corporations that use Maven are as follows. First we have Via Varejo, then comes Accenture, followed by JP Morgan Chase and Company, then comes Craftbase, and finally we have Red Hat.
First, understanding that what exactly is Gradle all about. Now, Gradle is a kind of a build tool which can be used for the build automation performance, and it can be used for various programming languages. Primarily, it's being used for the Java-based applications. It's a kind of build tool which can help you to see that how exactly automatically you can prepare the builds, you can perform the automations. Earlier, we used to do the build activity from the Eclipse, and we used to do it manually, right? But with the help of this build tool, we are going to do it like automatically without any manual efforts as such here. There are like a lot of activities which we will be doing during the build process. Primarily, there are different activities like compilations, linkage, packaging. These are the different tasks which we perform during the build process, so that we can understand that how the build can be done and we can perform the automations. This process also, it's kind of standardized, because again, if you want to automate something, standards or a standard process is something which we require for that before we being going ahead with that part. So that's the reason why we are getting this build tool, because this build tool helps us to do a standardization process to see that how the standards can be met and how we can proceed further with that part. Also, it's something which can be used for a variety of languages, programming languages. Java is the primary language for which we use the Gradle, but again, other languages like Scala, Android, C, C++, Groovy, these are some of the languages for which we can use the same tool. Now, it's actually using, like, it's referring to as a Groovy based domain specific language rather than XML, because Ant and Maven, these are the XML based build tools, but this one is not that dependent on XML. It's using the Groovy based domain specific language. DSL language is being used here. Right now, again, it's something which can be used to do the build. It can further on be used to perform the test cases automations also there, and then further on you can deploy to the Artifactory also, that okay, I want to push the artifacts to the Artifactory, so that part also you can get it done over here. So primarily this tool is known for doing the build automations for the big and large projects, the projects in which the source code, the amount of source code and the efforts is more. So in that case, this particular tool makes sense. Now, Gradle includes both the pros of Maven and Ant, but it removes the drawbacks or whatever the issues which we face during these two build tools. So it's helping us to remove all the cons which we face during the implementation of Ant and Maven, and again all the pros of Ant and Maven is implemented with this Gradle tool. Now let's see that why exactly this Gradle is used, because that's a very valid question, that what is the activity, like what is the reason why we use the Gradle. Because the first one is that it resolves issues faced on other build tools. That's a primary reason, because we all already having the tools like Maven and Ant which is available there, but primarily this Gradle tool is something which is removing all the issues which we are facing with the implementation of other tools. So these issues are getting removed as such. Second one is that it focuses on maintainability, performance, and flexibility. So it's giving the focus on that how exactly we can manage the big large projects, and we can have flexibility that what different kind of projects I want to build. Today I want to build in different ways, tomorrow the source code modifies, gets added up, so I have the flexibility that I can change this build scripts, I can perform the automations. So a lot of flexibility is available which is being supported by this tool. And then the last one is like it provides a lot of features, a lot of plugins. Now this is one of the benefit which we get in the case of Maven also, that we get a lot of features. But again, when we talk about Gradle, then it provides a lot of plugins. Like let's say that normally in a build process we do the compilation of the source code, but sometimes let's say that we want to build an Angular or a Node.js application. Now in that case we may be involved in running some command line executions, some command line commands, just to make sure that yes, we are running the commands and we are getting the output. So there are a lot of features which we can use, like there are a lot of plugins which is available there, and we will be using those plugins in order to go ahead and in order to execute those build process and doing the automations. Now let's talk about the Gradle and Maven, because again, when we talk about Maven, like it was like something which was primarily used for the Java, but again when we are talking about Gradle, so again it's just being used primarily for the Java here. But what is the reason that we prefer Gradle over the Maven? So what are the different reason for that? Let's talk about that part, because this is very important. We need to understand that what is the reason that Gradle is preferred as a better tool for the Java as compared to Maven when we talk about for the build automation here. Now the first one is that the Gradle using the Groovy DSL language, domain specific language, whereas the Maven is considered as a project management tool which is creating the POMs or XML format files. So it's being used for the Java project, but XML format is being used here. And on the other hand, Gradle is something which is not using the XML formats, and whatever the build scripts you are creating, that is something which is there in the Groovy based DSL language. And on the other hand, in the POM we have to create the XMLs, dependencies, whatever the attributes you are putting up in the Maven, that's something which is available there in the format of XML. The overall goal of the Gradle is to add functionality to a project, whereas the goal of the Maven is to to complete a project phase, like to work on different project phase, like compilation, test executions, then packaging, so then deploying to Artifactory. So these are all different phases which is available there into the Maven. But on the other hand, Gradle is all about adding the functionality, that how you want to have some particular features added up into the build scripts. In Gradle, there are, like, we usually specify that what are the different tasks we want to manage. So different tasks we can add up into the case of Gradle, and we can override those tasks also. In case of Maven, it's all about the different phases which is being happening over here, and it's in sequence manner. So these phases happens in the sequence order, that how exactly you can build up the sequence there. But in case of Gradle, you can have your own tasks, custom tasks also, and you can disrupt the sequence, and you can see that how the different steps can be executed in a different order. So Maven is something which is a phase mechanism there, but Gradle is something which is according to the features or the flexibilities. Now Gradle works on the tasks, whatever the task you want to perform, it works directly on those tasks there. On the other hand, Maven is something does not have any kind of inbuilt cache, so every time you are running the build, so separate things or the plugins and all this information gets loaded up, which takes definitely a lot of time. On the other hand, Gradle is something which is using its own internal cache, so that it can make the builds a little bit faster, because it's not something which is doing the things from the scratch. Whatever the things is already being available in the cache, so it's just pick that part, and from there it will proceed further on the build automation. And that's the reason why Gradle performance is much faster as compared to Maven, because it uses some kind of a cache in there, and then helps to improve the overall performance. Now let's talk about the Gradle installation, because this is a very important aspect to be done, because when we are doing the installation, we have to download the Gradle executables. right? So let's see that what are the different steps is involved in the process of the Gradle installation. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the Open JDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output at whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably, in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one. Right now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see like we will give this path here. There is 2 environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle_home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these 2 variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd Java version to check the version of the Java, and then the Gradle underscore version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it shows that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system. So let's go back to the content. Let's talk about the Gradle core concepts here. Now in this one, we are going to talk about what are the different core concepts of Gradle are all about. The very first one is the projects here. Now a project represents an item to be performed over here, to be done, like deploying an application to a staging environment, performing some build. So Gradle is something which is required. The projects, the Gradle project which you prepare is not having multiple tasks which is available there, which is configured, and all these tasks, all these different tasks needs to be executed into a sequence. Now sequence is again a very important part, because again if the sequence is not met properly, then the execution will not be done in a proper order. So that's the very important aspect here. Tasks is the one in which is a kind of an entity in which we will be performing a series of steps. These tasks may be like compilation of a source code, preparing a jar file, preparing a web application archive file, or a ER file. Also we can have, like, in some tasks we can even publish our artifacts to the artifact tree, so that we can store those artifacts into a shared location. So there are different ways in which we can have this particular tasks executed. Now build scripts is the one in which we will be storing all this information. What are the dependencies, what are the different tasks we want to refer. It's all going to be present in the build.gradle file there. Build.gradle file will be having the information related to what are the different dependencies you want to download and you want to store there. So all these things will be a part of the build scripts. Now let's talk about the features of Gradle. What are the different features which we can use in case of Gradle here. There are different type of features which is available there. So let's talk about them one by one. So the very first one over here is the high performance. Then high performance is something which we can see that we already discussed, that in case you are using a large projects, so Gradle is something which is in better approach as compared to Maven, because of the high performance which we are getting. It uses an internal cache which makes sure that you are using, like, you are doing the builds faster, and that can give you a higher performance over there. Second one is the support. It provides the support. So it, yes, definitely provides a lot of support on how you can perform the builds, and it's being the latest tool which is available there. So the support is also quite good in terms of how you want to prepare the build, how you want to download the plugins, different plugin supports, and the dependencies information also there. Next one is multi-project build software. So using this one you can have multiple projects. In case in your repository you have multiple projects here, so all of them can be easily built up with the help of this particular tool. So it supports multiple projects to be built up using the same Gradle project and Gradle scripts. So that support is also available with this Gradle build tool. Incremental builds are also something which you can do with the help of Gradle. So if you have done only the incremental changes and you want to perform only the incremental build, so that can also be possible with the help of Gradle here. The build scans, so we can also perform the build scans. So we can use some integrations with SonarQube and all, where we can have the scans done to the source code, on understand on how the build happens or how the source code really happens on there. So that code scan or the build scans can also be performed with this one. And then it's a familiarity with Java. So for Java, it's something which is considered as an by default. Not even Java, in fact Android, which is also using the Java programming language, is using the particular Gradle over here, so that the build can be done and it can gain benefits out of that. So in all the manners, in all the different ways, it's basically helping us to see that how we can make sure that this tool can help us in providing a lot of features, and that can help us to make a reliable build tool for our Java based projects or any other programming based project here. Right, now let's see that how we can onboard a Java project with the Gradle here, and for that we have to go back, and Gradle is something which is already installed. We just have to create a directory where we can have, like, how we can perform some executions, we can prepare some build scripts, and we can have a particular execution of a Gradle build happened over there. So let's go back to the machine. Okay, so we are going to open the terminal here and we'll see that how we can create it. So first of all, I have to create a directory structure. Let's say that we'll say like Gradle -project. Now once the project is created, so we can go inside this directory, so to create some Gradle related projects and preparing the files. Now in this one, let's first create a particular one. So we will be saying like vi build dot Gradle. So in this one we are going to put like two plugins we are going to use. So we are going to say like apply plugin Java, and then we are going to say like apply plugin application. So these two plugins we are going to use, and when we got this file over here in this one, so it shows like build.gradle, which is available there in this case. So two these files are available. Now if you want to learn like what are the different tasks, so you can run like Gradle tasks command over there. So Gradle task will help you know that what are the different tasks which is available over here by processing the build scripts and all. So this will definitely help you to understand on giving you the output. So here all the different tasks are being given, and it will help you to understand that what are the different tasks you can configure and you can work over here, just like jar files, clean and all that stuff, build, compile, then init is there, then all these different executions, assemble, then java dog, then build, then check, test, all these different tasks are there. And if you really want to run the Gradle build, so you can run like Gradle clean to perform the clean activity, because right now you are doing like a build, so before that you can have a clean, and then you can run a specific command, or you can run the Gradle clean build, which will perform the cleanup also, and it will at the same time will have the build process also performed over there. So build and cleanup both will be executed over here, and what is the status, whether it's a success or a failure, that will be given back to you. Now in this case, in the previous one, if you see that when you ran the Gradle clean, it was only running one task, but when you go for the build process, when you run the Gradle clean build, it's going to give you a much more information. In fact, you can also give me further information, like you can have the -info flag also there, so that if you want to get the details about the different tasks which is being executed over here, so that also you're going to get over here in this one. So you just have to put like -info, and then all these steps will be given back to you, that how these tasks will be executed and the response will be there. So that's a way that how you can create a pretty much simple straightforward project in form of Gradle, which can definitely help you to run some couple of Gradle commands, and then you can understand that what are the basic commands you can run and how the configurations really works on there, right? Let's go back to the main content. Right, now let's move on to the next one. So in the next one we are going to see that how we can prepare a Gradle build project in case of Eclipse. Now we are not using the local system, we are not directly creating the folders and the files here, we are actually using the Eclipse for creating a new Gradle project over here. So let's move on that part. Okay, so now the Eclipse is open, and I have opened in this one. The very first thing is that we have to do the Gradle plugin installation so that we can create new projects on Gradle, and then we have to configure the path, that how the Gradle plugin can be configured on the preferences and all that stuff, and then we will be doing the build process. So the very first thing is that we have to go to the Eclipse marketplace. In there we have to search for Gradle. So once the search is done, it will show us the plugins related to Gradle. So we have to go for build ship Gradle integration. So we'll click on the install. It will proceed with installation. It will download it. In some cases, maybe it's part of the Eclipse as in the ID. So you can go to the installed tab and you can see that also, that if this plugin is already installed or not. But in this case, we are installing it. And once the installation is done, we just have to restart the specific ones. We have to restart this Eclipse so that the changes can be reflected. So it's downloading the Gradle here, and once that is installed, we will be able to use it over here in this case, in this scenario. So we have to just wait for that part. So still downloading the jar files. So once the jar file is done, it's now over the areas and downloaded. So after that, we will be able to proceed further on that download aspect. So it's going to take some time to download it, and once it's done, we will be able to proceed further. Now once the progress is done, so it's asking us for the restart now. So before that, we just have to click on restart now, and then the Eclipse will be restarted altogether again here. So you can do it manually, or you can go for that options. It just require a restart so that the new changes can be reflected over here. So the plugins can be activated and can be referenced here. Now we have to just put up like the the configuration where we can have the system. So we can go for the Gradle configuration. So we can go for Windows and then preferences. Now in this case we have to go for the ones in which the Gradle option is available there. So Gradle is what we are going to select. Now user home, the Gradle user home is what we need to use, right? So you want to go for the Gradle, you want to go for local installation. So all these options you can use. You can, if you go for the Gradle wrapper, then it will be downloading the Gradle locally, and it is going to use the Gradle W or gradlew.bat file. But if you already have an installation locally, so you can prefer that also, right? Now in the previous demo we have already got the Gradle extracted, so we just have to go for the downloads. In the downloads already Gradle is available, so we are going to select that part here. So this is what we are going to select, right? So this represents that this is the directory structure in which we are having the mechanism. So you can either go for the build scan, so you can select the build scan also. So once this is enabled, then all the projects will be scanned and will be published, and it's in kind of additional option which is available. If you really want to disable it, you can disable it also, and you can go with this configuration also. So this is where the particular Gradle folder is being put over here in this case, and then we have to just click on apply, and we just have to click on apply and close. So with this one, the particular execution is done. Now we will be going for the project creation, so you can right click over here, or you can go to the file also. So here we are going to go for the job project, and in this we are going to have a Gradle project. So Gradle project is what we are going to create here. And next, so we are going to say like Gradle project, and then next. So once that is done, so finish. So with this one, when you create the project, so what will happen that automatically there will be a folder structure will be available there, right? And there are some Gradle scripts which will also be created there. So we will be doing the modifications to there, and we'll see that how the particular Gradle build script looks like, and how we will be adding some couple of Selenium related dependencies, and we'll see that how we can have more and more dependencies added, and what will be the impact of those dependencies on the overall project. So that also it's very important aspect to be considered. So let this processing be happen over there. It's just creating, and some plugins and binaries are getting installed and getting downloaded. So we'll see that once the project is imported, completely executed over here and got created, we can extract that. Now if you see here, the particular option is available about the Gradle tasks, so you can extract it also, and you will be able to know that what are the different tasks which is available there. Let's see that in the build they are running like build. These are the different tasks which is happening inside the build process. So Gradle executions will be also available over here in this case, and Gradle tasks will be different. It will be represented over here in this one. So you just have to extract on the Gradle build project. Okay, so this is the library which is available. Now what happens that you will be able to have like settings.gradle. In this one you will be able to have like, okay, Gradle -project is something which is available there in this one, so that's what I'm being referring. Then we have over here as in these folder structures which is created like source, main, Java. This is the one. Source, test, Java is the one which is available as in the folder structure, and source, test, resources are also available here. So the main source, main, resources are also available. Now in this case what happens that these are the dependencies, project and external, these are the different dependencies are available there. So let's see, let's add a dependency over here in this one in the build.gradle script, and see that how we can do that. If we open build.gradle file, so you can see that these dependencies are there, like test implementation, JUnit is available there, right? And then we have a implementations of this one which is available. Now these jar files when you put up, it will automatically be added up as in part of this one, as in part of the particular dependencies over here, and which means that you don't have to store them as an within the repository, and automatically they can be happened over there. So let's open a dependency page. So we will be going to Maven repository, where we will be opening a dependency link. So this is the dependency link here. So Selenium-Java is available, and it can give you the dependency for all the different options. Now we have for Maven, this is the one, and for Gradle, this is the one here. So we have to just copy this one, and we have to use it as a dependency. So this is the group, and this is the name and the version which we are using here. Now we have copied this one, so we will go back to the Eclipse. So here we have to just put that dependency, and we have to just save it. So this is something which is providing like Selenium dependencies which is available. So now we have to just refresh the project. So right click over here, then you will be able to see the options in the Gradle saying that refresh Gradle project. Now once the moment you do that, so you will be able to do, like, for the first time maybe it will take some time to download all the dependencies which is related to Selenium, but after that you will be able to see like the dependencies will be simply added up over here in this case. So you can see that all the Selenium related dependencies are added up. For any reason, if you comment these ones and you say like synchronize again, so you will see that all the dependencies which you are adding up from this Selenium from the Selenium perspective will be gone back again. So this is the way that how you can keep on adding the dependencies which is required for preparing your build for your source code, and from there you will be able to proceed further on the execution part. So that's the best part about this Gradle here. So that's a way that how we are going to prepare a Gradle project within the Eclipse, and now you can keep on adding like the source code in this one, and that's the way that how the code base will be added up over here. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the Open JDK or you can go for the Oracle Java. So you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one, right? Now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see, like, we will give this path here. There is two environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle_home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd Java version to check the version of the Java, and then the Gradle_version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it shows that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system.
The birth of Selenium. Selenium was primarily created by Jason Huggins in 2004. Jason, an engineer at ThoughtWorks, was working on a web application that needed to be tested frequently. He realized that the repeated manual testing of the application is becoming inefficient. So he created a JavaScript language that automatically controlled the browser's actions. This program was named JavaScript Test Runner. After he realized that his idea of automating the web applications has a lot of potential, he made the JavaScript Test Runner open source, and it was later renamed as Selenium Core. So we know that Jason was the person who initially created Selenium. But then we must also know that Selenium is a collection of different tools, and since there are different tools, there will be several developers too. To be exact about the number of different tools, there are 4 different tools that have their own creators. Let's have a look at all of them. The first tool is the Selenium Remote Control, or the Selenium RC, that was created by Paul Hammond. Then comes Selenium Grid, that was developed by Patrick Lightbody. The third tool is the Selenium IDE, that was created by Shinya Kasatani, and the fourth tool, that is the Selenium WebDriver, was created by Simon Stewart. We shall be learning about all these tools in great detail as we move forth in our video. First, let's have a look at what is Selenium. Selenium is a very popular open source tool that is used for automating the tests carried on the web browsers. There may be various programming languages like Java, C#, Python, etc. that could be used to create Selenium test scripts. This testing that is done using Selenium tool is referred to as Selenium testing. We must understand that Selenium allows the testing of web applications only. We can neither test any computer software nor any mobile application using Selenium. Selenium is composed of several tools with each having its own specific role and serving its own testing needs. Moving forth, let's have a look at the features of Selenium, which will help us understand the reason behind its widespread popularity. So here we have a set of features of Selenium. Selenium is an open source and portable framework that has a playback and record feature. It is one of the best cloud-based testing platforms and supports various OS and languages. It can be integrated with several testing frameworks and supports parallel test execution. We will be talking about all these features in detail as we move forward. So here, the first feature that we have is open source and portable framework. This feature states that Selenium is an open source and portable framework for testing web applications. In addition to that, Selenium commands are categorized in terms of different classes, which make it easier to understand and implement. The second feature is the playback and record feature. The feature states that the tests can be authorized without learning a test scripting language with the help of playback and record features. The next feature says that Selenium is a cloud-based testing platform. Selenium is a leading cloud-based testing platform that allows testers to record their actions and export them as a reusable script with a simple to understand and easy to use interface. Moving forth, the next feature states that Selenium supports various operating systems, browsers, and programming languages. The tool supports programming languages such as C#, Java, Python, PHP, Ruby, Perl, and JavaScript. If we talk about the operating systems, then Selenium supports operating systems like Android, iOS, Windows, Linux, Mac, and Solaris. And the tool also supports various browsers like Google Chrome, Mozilla Firefox, Internet Explorer, Edge, Opera, Safari, etc. Then the next feature we have is the integration with testing frameworks. Selenium can be well integrated with testing frameworks like TestNG for application testing and generating reports. And also, Selenium can be integrated with frameworks like Ant and Maven for source code compilation. The last feature in our list is the parallel test execution. Selenium enables parallel testing, which reduces time and increases the efficiency of the tests. Selenium requires fewer resources as compared to other automation testing tools. Now, let's move further and get to know different Selenium tools. By now we know that there are 4 different tools that come under the Selenium suite. The 4 tools are Selenium Remote Control, Selenium Grid, Selenium IDE, and Selenium WebDriver. We shall have a look at these 4 tools in detail one after the another. Beginning with Selenium Remote Control. Selenium Remote Control enables the writing of automated web applications in languages such as Java, C#, Perl, Python, and PHP to build complex tests such as reading and writing files, querying a database, and emailing the test results. Selenium RC was a sustainable project for a very long time before Selenium WebDriver came into existence, and hence Selenium RC is hardly in use today, as the WebDriver offers more powerful functionalities. The second tool we shall see is the Selenium Grid. Selenium Grid is a smart proxy server that enables the running of tests in parallel on several machines. This is made possible when the commands are routed to the remote web browser instances and one server acts as the hub. The hub here is responsible for conducting several tests on multiple machines. Selenium Grid makes cross-browser testing easy as a single test can be carried on multiple machines and browsers altogether, making it easy to analyze and compare the results. Here, there are 2 main components of Selenium Grid, Hub and the node. Hub is a server that accepts the access request from the WebDriver client, routing the JSON test commands to the remote drivers on nodes. And here, the node refers to the remote device that consists of a native OS and a remote WebDriver. It receives the request from the hub in the form of a JSON test commands and executes them using the WebDriver. Moving forth, the third tool is the Selenium IDE. If you want to begin with the Selenium IDE, it needs no additional setup except installing the extension of your browser. It provides an easy-to-use tool that gives instant feedbacks. Selenium IDE records multiple locators for each element it interacts with. If one locator fails during the playback, the others will be tried until one is successful. The IDE makes the test debugging easier with features like setting breakpoints and pausing exceptions. Through the use of the run command, you can reuse one test case inside one another. And also, Selenium IDE can be extended through the use of plugins. They can introduce new commands to the IDE or integrate with a third-party service. The last and the fourth tool in the Selenium suite is the Selenium WebDriver. Selenium WebDriver is the most critical component of the Selenium tools suite that allows cross-browser compatibility testing. The WebDriver supports various operating systems like Windows, Mac, Linux, Unix, etc. It provides compatibility with a range of languages including Python, Java, and Perl. Along with it, it provides supports different browsers like Chrome, Firefox, Opera, Safari, and Internet Explorer. The Selenium WebDriver completes the execution of test scripts faster when compared to other tools, and also it provides compatibility with iPhone driver, HTML unit driver, and Android driver. Now, after you know about the tools, the question arises which tool to choose. So in the next topic, we shall see different factors on the basis of which we may decide which tool would be more suitable for us. Here, we shall have a look at the reasons why one should choose that particular tool. We shall begin with Selenium Remote Control. Selenium Remote Control or Selenium RC should be chosen to design a test using a more expressive language than Selenese. Selenese is a set of Selenium commands that are used to test our web applications. Then the Selenium RC might be chosen to run tests against different browsers on different operating systems. The RC may be chosen to deploy tests across multiple environments using Selenium Grid. It helps in testing the applications against a new browser that supports JavaScript and web applications with complex AJAX-based scenarios. Now, the second tool for which we shall see the reasons are Selenium Grid. Selenium Grid, as we learnt in the reasons for Selenium RC, is used to run Selenium RC scripts in multiple browsers and operating systems simultaneously. The grid is used to run a huge test suite that needs to be completed at the earliest possible time. Now comes the third tool. The third tool is Selenium IDE. Selenium IDE is used to learn about concepts on automated testing and Selenium. These concepts include Selenese commands such as type, open, click and wait, assert, verify, etc. The concepts also include locators such as ID, name, XPath, CSS selector, etc. Selenium IDE enables the execution of customized JavaScript code using run script and exporting test cases in several different formats. The IDE is used to create tests with a limited amount of knowledge in programming, and these test cases and test suites can be exported later to RC or WebDriver. Now finally, let's have a look at the reasons to choose a last tool, that is Selenium WebDriver. Selenium WebDriver uses a certain programming language in designing a test case. The WebDriver is used to test applications that are rich in AJAX-based functionalities, execute tests on HTML unit browser, and create customized test results.
So this is what we're going to be covering in this session. We're going to cover what life is like before using Jenkins and the issues that Jenkins specifically addresses. Then we'll get into what Jenkins is about and how it applies to continuous integration and the other continuous integration tools that you need in your DevOps team. Then specifically, we'll deep dive into features of Jenkins and the Jenkins architecture, and we'll give you a case study of a company that's using Jenkins today to actually transform how their IT organization is operating. So let's talk a little bit about life before Jenkins. Let's see this scenario. I think it's something that maybe all of you can relate to. As developers, we all write code and we all submit that code into a code repository, and we all keep working away, writing our unit tests, and hopefully we're running our unit tests. But the problem is that the actual commits that actually get sent to the code repository aren't consistent. You as a developer may be based in India, you may have another developer that's based in the Philippines, and you may have another team lead that's based in the UK, and another development team that's based in North America. So you're all working at different times, and you have different amounts of code going into the code repository. There's issues with the integration, and you're kind of running into a situation that we like to call development hell, where things just aren't working out and there's just lots of delays being added into the project, and the bugs just keep mounting up. The bottom line is the project is delayed. And in the past, what we would have to do is we'd have to wait until the entire software code was built and tested before we could even begin checking for errors. And this just really kind of increased the amount of problems that you'd have in your project. The actual process of delivering software was slow. There was no way that you could actually iterate on your software, and you just ended up with just a big headache with teams pointing fingers at each other and blaming each other. So let's jump into Jenkins and see what Jenkins is and how it can address these problems. So Jenkins is a product that comes out of the concept of continuous integration that you may have heard of as power developers, where you'd have two developers sitting next to each other coding against the same piece of information. What they were able to do is to continuously develop their code and test their code and move on to new sections of code. Jenkins is a product that allows you to expand on that capacity to your entire team. So you're able to submit your codes consistently into a source code environment. So there are two ways in which you can do continuous delivery. One is through nightly builds and one is through continuous. So the approach that you can look at continuous delivery is modifying the legacy approach to building out solutions. So what we used to do is we would wait for nightly builds, and the way that our nightly builds would work and operate is that as code developers, we would all run and have a cutoff time at the end of the day that was consistent around the world, that we would put our codes into a single repository. And at night, all of that code would be run and operated and tested to see if there were any changes, and a new build would be created. And that would be referred to as the nightly build. With continuous integration, we're able to go one step further. We're able to not only commit our changes into our source code, but we can actually do this continuously. There's no need to race and have a team get all of their code in at an arbitrary time. You can actually do a continuous release, because what you're doing is you're putting your tests and your verification services into the build environment. So you're always running cycles to test against your code. This is the power that Jenkins provides in continuous integration. So let's dig deeper into continuous integration. So the concept of continuous integration is that as a developer, you're able to pull from a repository the code that you're working on, and then you'll be able to then at any time submit the code that you're working on into a continuous integration server. And the goal of that continuous integration server is that it actually goes ahead and validates and passes any tests that a tester may have created. Now, if on the continuous integration server a test isn't passed, then that code gets sent back to the developer, and the developer can then make their changes. It allows the developer to actually do a couple of things. It allows the developer not to break the build, and we all don't want to break the builds that are being created, but it also allows the developer not to actually have to run all of the tests locally on their computer. Running tests, particularly if you have a large number of tests, can take up a lot of time. So if you can push that service off to another environment, like a continuous integration server, it really improves the productivity of your developer. What's also good is that if there are any code errors that have come up that may be beyond just the standard CI test, so maybe there's a code, the way that you write your code isn't consistent, those errors can then be passed on easily from the tester back to the developer too. The goal from doing all of this testing is that you're able to release and deploy, and your customer is able to get new code faster, and when they get that code, it simply just works. So let's talk a little bit about some of the tools that you may have in your continuous integration environment. So the cool thing with working with continuous integration tools is that they are all open source, or at least the ones that we have listed here are all open source. There are some that are private, but typically you'll get started with open source tools, and it gives you the opportunity to understand how you can accelerate your environment quickly. So Bamboo is a continuous integration tool that specifically runs multiple builds in parallel for faster compilation. So if you have multiple versions of your software that runs on multiple platforms, this is a tool that really allows you to get that up and running super fast so that your teams can actually test how those different builds would work for different environments. And this has integration with Ant and Maven and other similar tools. So one of the tools you're going to need is a tool that allows you to automate the software build, test, and release process. And BuildBot is that open source product for you. Again, it's an open source tool, so there's no license associated with this. So you can actually go in and you can actually get the environment up and running, and you can then test for and build your environment and create your releases very quickly. So BuildBot's also written in Python, and it does support parallel execution jobs across multiple platforms. If you're working specifically on Java projects that need to be built and tested, then Apache Gump is the tool for you. It makes all of those projects really easy. It makes all the Java projects easier for you to be able to test with API level and functionality level testing. So one of the popular places to actually store code and create versioning of your code is GitHub, and it's a service that's available on the web, just recently acquired by Microsoft. If you are storing your projects in GitHub, then you'll be able to use Travis Continuous Integration, or Travis CI, and it's a tool designed specifically for hosted GitHub projects. And so finally, we're covering Jenkins, and Jenkins is a central tool for automation for all of your projects. Now, when you're working with Jenkins, sometimes you'll find that there's documentation that refers to a product called Hudson. Hudson is actually the original version of the product that finally became Jenkins, and it was acquired by Oracle. When that acquisition happened, the team behind Hudson was a little concerned about the direction that Oracle may potentially go with Hudson, and so they created a hard fork of Hudson that they renamed Jenkins, and Jenkins has now become that open source project. It is one of the most popular and continuously contributed projects that's available as open source, so you're always getting new features being added to it. It's a tool that really becomes the center for your CI environment. So let's jump into some of those really great features that are available in Jenkins. So Jenkins itself is really comprised of 5 key areas around easy installation, easy configuration, plugins, extensibility, and distribution. So as I mentioned, for the easy installation, Jenkins is a self-contained Java program, and that allows it to run on most popular operating systems, including Windows, Mac OS, and Unix. You can even run it on Linux. It really isn't too bad to set up. It used to be much harder than it is today. The setup process has really improved. The web interface makes it really easy for you to check for any errors. In addition, you have great built-in help. One of the things that makes tools like Jenkins really powerful for developers and continuous integration teams and your DevOps teams as a whole, when you have plugins that you can then add in to extend the base functionality of the product. Jenkins has hundreds of plugins, and you can go and visit the update center and see which other plugins that would be good for your DevOps environment. Certainly check it out. There's just lots of stuff out there. In addition to the plugin architecture, Jenkins is also extremely extensible. The opportunity for you to be able to configure Jenkins to fit in your environment is almost endless. Now, it's really important to remember that you are extending Jenkins, not creating a custom version of Jenkins. And that's a great differentiation because the core foundation remains as the core Jenkins product. The extensibility can then be continued with newer releases of Jenkins. So you're always having the latest version of Jenkins and your extensions mature with those core foundation. The distribution and the nature of Jenkins makes it really easy for you to be able to have it available across your entire network. It really will become the center of your CI environment, and it's certainly one of the easier tools and more effective tools for DevOps. So let's jump into the standard Jenkins pipeline. So when you're doing development, you start off and you're coding away on your computer. The first thing you have to do when you're working in the Jenkins pipeline is to actually commit your code. Now, as a developer, this is something that you're already doing, or at least you should be doing. You're committing your code to a Git server or to an SVN server or a similar type of service. So in this instance, you'll be using Jenkins as the place for you to commit your code. Jenkins will then create a build of your code, and part of that build process is actually going through and running through tests. And again, as a developer, you're already comfortable with running unit tests and writing those tests to validate your code. But there may be additional tests that Jenkins is running. So for instance, as a team, you may have a standard set of tests for how you actually write out your code so that each team member can understand the code that's been written. And those tests can also be included in the testing process within the Jenkins environment. Assuming everything passed the tests, you can then get everything placed in a stage and release ready environment within Jenkins. And finally, you're getting ready to deploy or deliver your code to a production environment. Jenkins is going to be the tool that helps you with your server environment to be able to deploy your code to the production environment. And the result is that you're able to move from a developer to production code really quickly. This whole process can be automated. Rather than having to wait for people to actually test your codes or going through a nightly build, you're looking at being able to commit your code and go through this testing process and release process continuously. As an example, companies Etsy will release up to 50 different versions of their website every single day. So let's talk about the architecture within Jenkins that allows you to be so effective at applying a continuous delivery DevOps environment. So the server architecture really is broken up into two sections. So on the left-hand side of the section, you have the code the developers are doing and submitting that code to a source code repository. And then from then, Jenkins is your continuous integration server. And it will then pull any code that's being sent to the source code repository and will run tests against it. It will use a build service such as Maven to actually then build the code. And at every single stage that we have that Jenkins manages, there are constant tests. So for instance, if a build fails, that feedback is sent right back to the developers so that they can then change their code so that the build environment can run effectively. The final stage is to actually execute specific test scripts. And these test scripts can be written in Selenium. So it's probably good to mention here that both Maven and Selenium are plugins that run in the Jenkins environment. So before we were talking about how Jenkins can be extended with plugins, Maven and Selenium are just two very popular examples of how you can extend the Jenkins environment. The goal to go through this whole process, again, it's an automated process, is to get your code from the developer to the production server as quickly as possible, have it fully tested, and have no errors. So it's probably important at this point to mention one piece of information around the Jenkins environment, that if you have different code builds that need to be managed and distributed, this will require that you need to have multiple builds being managed. Jenkins itself doesn't allow for multiple files and builds to be executed on a single server. You need to have a multiple server environment with running different versions of Jenkins for that to be able to happen. So let's talk a little bit about the master-slave architecture within Jenkins. So what we have here is an overview of the master-slave architecture within Jenkins. On the left-hand side is the remote source code repository. And that remote source code repository could be GitHub, or it could be Team Foundation Services, or the new Azure DevOps code repository, or it could be your own Git repository. The Jenkins server acts as the master environment on the left-hand side, And that master environment can then push out to multiple other Jenkins slave environments to distribute the workload. So it allows you to run multiple builds and tests and production environments simultaneously across your entire architecture. So Jenkins slaves can be running the different build versions of the code for different operating systems, and the server master is controlling how each of those builds operate. So let's step into a quick story of a company that has used Jenkins very successfully. So here's a use case scenario. Over the last 10 or 15 years, there has been a significant shift within the automotive industry where manufacturers have shifted from creating complex hardware to actually creating software. We've seen that with companies such as Tesla, where they are creating software to manage their cars. We see the same thing with companies such as General Motors with their OnStar program. And Ford just recently have rebranded themselves as a technology company rather than just an automotive company. What this means, though, is that the software within these cars is becoming more complex and requires more testing to allow more capabilities and enhancements to be added to the core software. So Bosch is a company that specifically ran into this problem, and their challenge was that they wanted to be able to streamline the increasingly complex automotive software by adopting continuous integration and continuous delivery best practices, with the goal of being able to delight and exceed the customer expectations of the end user. So Bosch has actually used CloudBees, which is the enterprise Jenkins environment. So to be able to reduce the number of manual steps such as building, deploying, and testing, Bosch has introduced the use of CloudBees from Jenkins. And this is part of the enterprise Jenkins platform. It has significantly helped improve the efficiencies throughout the whole software development cycle, from automation, stability, and transparency, because Jenkins becomes a self-auditing environment. Now, the results have been tangible. Previously, it took 3 days before a build process could be done, and now it's taken that same 3-day process and reduced it to less than 3 hours. That is significant. Large-scale deployments are now kept on track and have expert support, and there is clear visibility and transparency across the whole operations through using the Jenkins tools.
Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store their data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily, How easily, one might ask. It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital costs. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries. Using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service, Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL, or American Online, uses AWS, and using AWS, they have been able to close data centers and decommission about 14,000 in-house and co-located servers, and move mission-critical workload to the cloud, and extend its global reach, and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FD is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads, including 300 disparate ERP systems, to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data, and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy to use service for deploying and scaling web applications, and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere, websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS Auto Scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Auto Scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born, like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage. And S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment. And CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing, and now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto-scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? All right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL.
Welcome to the realm of cutting-edge technology. Have you ever wondered what it would like to harness the immense power of Google's computing infrastructure right at your fingertips? Look no further, for in digital realm that there exists a phenomenon known as Google Collab, an interesting fusion of cloud computing and collaborative prowess. Imagine a world where you can effortlessly explore the limitless possibilities of artificial intelligence, machine learning, and data analysis without the need for expensive hardware or complex setups. Google Collab emerges as Celestial Sanctuary, offering you a virtual laboratory to experiment, create, and collaborate with like-minded enthusiasts from every corner of the globe. In this exciting video, we will understand what is Google Collab and then we will have a complete overview of it. So let's start with the first topic. What is Google Collab? So Google Collab is a free online tool that lets you do coding and data related work on the internet. It's like having a virtual notebook where you can write and run Python code without needing to install anything on your computer. With Collab, you can also get data from different places and share your work with others easily. Another cool thing is that it gives you access to powerful processors like GPUs and TPUs, which make tasks like machine learning and data science faster and more efficient. So it's a great tool for learning and working on coding and data projects. Alright, now let's have a look at Google Collab. Let's have a complete overview of it. So first of all, Google Collab requires a Google account for access. To begin, visit the link Welcome to Collaboratory. Right, Welcome to Collaboratory, as you can see. We'll click on this. Then we'll click on this, open this one, and sign in using our Google account or credentials. If you already have a Google account, then you can just sign in with that. Alright, now let's start with the Google Collab. We'll simply write Google Collab. We'll click on this. Alright, so this is the window that appears when you click on that. First of all, here we have is Example tab. So the Example tab offers some initial examples to help you begin using Collab. For a comprehensive understanding of collaborative features and efficient usage of Collab documents, refer to the document titled Overview of Collaborative Features. It covers the fundamental aspects to get you started efficiently. Then there is Recent tab. Alright, so the Recent tab displays a collection of all the latest documents you have been working on. Alright, now next is our Google Drive tab. The Google Drive tab features allows you to import any of your previous notebooks directly from your Google Drive. Alright, then next is GitHub tab. So with the GitHub tab, you have the option to import notebooks from your own GitHub repository or any public repository. Simply provide the GitHub URL and you can easily import notebooks from the desired public repository. Then we have is Upload tab. So the upload feature allows you to bring and work on your own Jupyter notebooks that you have created on your computer. You can easily upload any file from your local machine by selecting the Choose File option. Here it is, Choose File option. Now next is our creating a notebook. As we can see, here's a new notebook option and there's a cancel option. So creating a notebook. So to create a new notebook, you have the option to use the new notebook button located at the bottom. By clicking on this button, a new untitled notebook will be generated. To give it a specific name, and simply click on the current untitled name if we want to name it. So as we have clicked on it, To give it a specific name, as we just said, simply click on the current untitled name on the notebook and make the desired changes. So let's say we want to make it SP1. Let's just say it a name. Alright. So next is our cell. Here we can see this is a cell. In a notebook, cells serve as the fundamental building blocks encompassing everything within. There are two types of cells actually. One is code cell, as you can see. It contains executable code and has a run button on the left side to execute its content. This one. Alright. The output is displayed. Its output is displayed below the code cell after running. Right. Then the next one is, other one is text cell. So a text cell can include text, images, links and more. You can edit its content by double clicking it. The text cell supports Markdown markup language, but you can also use the provided options on the top for formatting. The right half of the cell shows you how your edited text will appear. Alright. Now the next point would be adding a new cell, like how to add a new cell. To add a new code or text cell, use the respective option at the top of the work area. As you can see, these code or text, by clicking on these we can add code cell and text cell. So clicking on any of these buttons creates a new cell right below the current one. You can, like, let's say we want to add this. So now we want to add this. You can add this also. Now you can rearrange the cell order using the arrow options located at the top right corner of each cell. As you can see, by using these we can do that. Yeah. The up arrow moves the cell one position up, while the down arrow moves it down by one position. As we can see. Now adding and running a code. Let's talk about this. So by default, Google Colab provides one initial code cell which can be supplemented with additional cells as desired. These cells serve as a platform for writing and executing Python code. For instance, let's consider the following code. Let's say, first of all, I have to let us delete all these. This one also. Yeah. So first of all, we'll try one code. Let's see how it goes. So I'll simply write the code print. Yeah. Print my favorite color is yellow. Alright, so now let's try to execute it. We can run it by clicking on this. It is running, executing. So as you can see, my favorite color is yellow is being printed. So you can either press on this play button to run the code, or you can press Ctrl plus enter to run the code. As you can see, Ctrl plus enter to run the cell. Now next is changing the order of the cell. So in Google Colab, you have multiple options for rearranging cells. You can utilize the up cell and down cell buttons located in the toolbar above the notebook. As we discussed previously, alternatively, you can employ keyboard shortcuts such as Ctrl Shift up or Ctrl Shift down to move the chosen cell up or down. Additionally, you have the flexibility to reorder cells by clicking on the cell number in the left gutter and dragging it to a different position. Alright, now deleting the current tab. So to delete the current tab in Google Colab, you can use the delete icon available over the top of the cell. This icon looks like a trash can and it will remove the selected cell from the notebook. As we can see, this is the trash can and this is just at the right above corner of the cell. By clicking on this, we can delete the tab. Alternately, you can also use the keyboard shortcut Ctrl plus M and D to delete the current cell. You can also right click on the cell and select delete cells from the context menu. As you can see, delete cell. Alright, now we will understand how to add datasets. So to add datasets from your local device, go to the left corner and click on the folder icon. As we can see, this is the left corner and this is the folder icon. We'll click on that. Now click on the upload icon and upload the desired file. This is the upload icon. We'll click on that. Now we can upload the desired file, whichever we want. Alright. You can also upload files by writing a particular command. Let's try writing that command, okay? So we'll write from google.collab import files. Let's import files. Alright. After that we'll write upload equals files dot upload. After that we'll put on brackets. Alright, now we'll press Ctrl and enter, and here we can see choose files. Now from here you can choose files, so both the ways you can upload files, I'm just telling. Now let's understand how to import libraries in Google Colab. So first of all we have to cancel upload. We'll click on this. Alright, so to import it we'll write import pandas as pd. Alright, after that we'll write pd.read. So here we are importing the CSV files actually. So we have to write like pd.read underscore CSV, and inside this we'll write a file. Let's say I have to check what all files, like this is the sample data files, right? So you have to write the file name actually which you want to import, that CSV file name. I'm writing sample underscore data. Alright, underscore test. The location you have to put .csv. So this is the location. Alright, so if we want to display 10 rows, we'll write df.head, we'll write 10. Now we'll press Ctrl and enter, and we can see 10 rows are being displayed. So this is how you can import and showcase the data and all. So this was about the Google Colab. We have covered major things in that, many important things in that. There must be many more things in that you will explore when you will start using it. So after understanding about Google Colab and hearing about various cloud technologies,
So let's take a little scenario of a developer and a tester before you had the world of Docker. A developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same of the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that on the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller.
So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the DevOps tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and code base, we use tools like Git and GitHub. For building, we use Gradle and Maven. Testing, we use Selenium. The integration between dev and ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, and you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space could also then be utilized for putting in software and applications that along. And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, in this instance a 4th application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the 4 main components that comprise of the Docker environment. The 4 components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker hub where it can be shared across your entire team. And from the Docker hub, users can get access to the Docker image and build their own new containers.
So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and so we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure. And you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system and he's coding away, and he has to get that code over to a tester. Now, what will happen is that tester will then typically in your traditional environment then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software but probably doesn't have all the development software, and certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because
when you're having to install software over and over again, you just keep repeating, doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of two key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say for instance you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get a image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on our local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac.
And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password. So let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 :80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this will actually show us on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it -name my. So this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment. And we'll put in the image name, which is Ubuntu. And -bin -bash. And it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So we want to rename the container. Let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename. And we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just
not in an active state, just what's known as in an exit state. So here we go. And there's my Docker. It's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exited state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container. We'll break up this presentation into 4 key areas. We're going to talk about life before Kubernetes, which some of you are probably experiencing right now. What is Kubernetes? The benefits that Kubernetes brings to you, particularly if you are using containers in a DevOps environment. And then finally, we're going to break down the architecture and working infrastructure for Kubernetes so you understand what's happening and why the actions are happening the way that they are. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into 2 distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the 2 different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software, one service on one piece of hardware. So your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, or for virtual machines, are not perfect either.
Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. And what you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time-consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware. And then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable, directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why, if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just really a natural evolution of this software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So what is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation. And there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes. And it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you'd experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable. It is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. Out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining. Or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from CPU and RAM for each container. So let's dig into the final area, which is the actual Kubernetes architecture. And we're going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a clustered-based architecture, and it's really about 2 key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves, and there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available. And it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure. And then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. You have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of four key areas which essentially control all of your nodes, and the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10-15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm. And Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pod, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction and part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on Ingress, and this is really the the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then will work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The scheduler, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally, you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the containers should be either killed, stop started, or updated. So finally, let's look at see where Kubernetes is being used by other companies. So Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer, increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services.
So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal.
Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched in February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have ExpressRoute. Now with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have virtual network. Now with virtual network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now, this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development, it could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices, for example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines, where these services are able to provide you a large amount of storage where data can be stored. Let's talk about Azure services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now all of this is possible in a matter of seconds with a large amount of customization. Now let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now with Service Fabric, you have a platform which enables you to create microservices. Now this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want, and the only thing you need to worry about is the code of the application. Everything other than that, that is the hardware requirements, are taken care of by Azure. Now let's have a look at the networking services. Firstly, we have the Azure CDN, or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have ExpressRoute. With ExpressRoute, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency. It increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. Domain Name Service, or Azure DNS, can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have Virtual Network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also it's very easy to manage and is highly available. Now let's talk about the storage services. First, we have data lake storage. Now with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now it comes of maximum use when you integrate it with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now Blob Storage provides a storage capacity for data. Now depending on how often a particular data is used, it is classified into different tiers. Now, all the data that is within the blob storage is unstructured data. Now, it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have queue storage. Now, with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have file storage. Now with file storage, you can perform file sharing with the help of the SMB protocol or the server message block protocol. Now this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have table storage. With table storage, you can deploy semi-structured datasets and an NoSQL key value store. Now this is used for creating applications which have a flexible data schema. And also considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that. And by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have logic apps. Now with this, you can create integration solutions which can connect applications that are important to your business. Now with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now with web apps, you can create, deploy and scale web applications according to business requirements. Now it supports both Windows and Linux platforms and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway. And you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now with SQL database, what you get is a relational cloud database service. Now this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now SQL database is also used extensively in migrating workloads to the cloud and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now this is a globally distributed multi-model database service. Now what this means is that with this, you can create applications which support NoSQL. It provides a high-grade security system, has high availability and low latency. Now this is usually used in situations where you have a diverse and highly unpredictable workload. Now let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you are given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it.
There are going to be 6 things that we're going to step through. The first is really looking at what is the world that many of you already work in today? How do you administer your networks and your systems today? Then we're going to look at how Chef can be the tool that really helps improve the efficiencies of creating a consistent operations environment. We're going to look at the tools and the components and the architecture that it takes to construct Chef. And then finally, we're going to take a use case of one of the many companies that is using Chef today to improve the efficiency of their operations environment. So let's take a step back at what life was like before Chef. This may well be the life that you're experiencing right now. So as a system administrator, typically the way that you work is that you are responsible for the uptime of all of the systems within your network. And you may have many systems that you are responsible for. Now, if one system goes down, that's not a problem, because as a system administrator, you can get notifications and you can jump right onto the problem and solve it. When things start getting really difficult, however, is when you have multiple systems and you are not able as a single person to get to all those systems and solve them as quickly as possible. The problem that you start having is that your environments are not in sync. If only this could all be automated. Well, this is where Chef comes to the rescue for you. So let me take some time and introduce you to the concepts behind Chef and why it's a tool that you would probably want to be using in your environment. So what actually is Chef? So Chef is a way in which you can use code to fix your physical hardware environment. So what does that look like? Well, the way that we write out scripts in Chef is that you can actually code your entire environment. So you don't have to actually be managing your environment on a hardware by hardware basis, but actually use scripts called recipes that will actually manage the environment for you. So Chef will actually ensure that every system is automatically set to the right states that meet the requirements that you have defined in your code. So you don't have any issues where hardware starts to fail, because it references the code to reset the state within that environment. And that makes you a happy system administrator. So let's go through the mechanics of how this actually works with Chef. So Chef is ultimately an automation tool that converts infrastructure to code. And you'll often hear the term infrastructure as code, or IAC. And this really starts as an output of the work that Chef has done. Because you take the policies that you as an organization have created and you convert that into a scripted language that can then be implemented automatically. This enables Chef to be able to manage multiple systems very, very easily. And considering how broad and deep our systems become, it's very easy to see how this can help you as a system administrator. The code is then tested continuously and deployed by Chef so that you're able to guarantee that your standards and appropriate states for your hardware and operating environment are always maintained. So let's step through the different components that are available in Chef. So the first one is actually creating the actual recipes for Chef. So you actually work on these on a workstation and you'll write out your code, which is referred to as a recipe. And that recipe will be written using a language called Ruby. Good thing for you is that there are lots of examples of Ruby recipes that have been created by the open source community. A lot of examples. Knife is the command tool that you use that communicates between the recipes and the server. So your recipe is the instruction and Knife is the tool that makes that instruction work and sets the appropriate state on the server environment. When you create more than one recipe, you start creating a collection. Those collections are referred to as cookbooks. And you may take an environment such as a large network where you have multiple nodes, potentially hundreds of servers that have to all have a consistent and equal state environment. And you would put that cookbook and use that cookbook to ensure with Chef that the state of each of those nodes is consistent. And then Ohai fetches the current state of your nodes, and then the Chef client configures the nodes as defined within your cookbook. So let's step through the architecture and working environment of Chef. So for an administrator, a systems administrator, you only have to now work from your workstation. And from that workstation, you can then configure all the nodes of your environment. You can use different recipes that you create, and those recipes can be compiled into a cookbook that can be then applied to a node. The thing that's of value is that as you change the environment, as you move and mature as an organization, and your nodes need to mature consistently and quickly with your organization, all you have to do is roll out a different recipe to your nodes, and then the nodes will use the tools within Chef to make the updates. So you can create a second recipe or even a third recipe to be deployed out to your server environment. Knife is going to be the tool that does the hard work of doing the updates on the server. With the server, you have your collection of recipes in a single cookbook. However, understanding the state of the individual nodes is important to ensure that the information is broadcast from the server with the instructions on how to set up the network within those nodes. In this instance, we use Ohai, and Ohai will fetch the state of the nodes and send that back to
the server and get the information from the cookbook using the Chef client. In your Chef node network, there is the potential at times that maybe one of your node fails. If there are 2 failed nodes, then a request is sent back to the server, and information on the latest node structure that is identified and defined in the cookbook will be sent to the failed nodes. If that fails to reset the nodes, then the workstation is notified and you as the administrator will receive a notification to manually reset those nodes. It should be noted that this is a very rare occasion within the Chef network setup. So let's step through a use case. In this instance, we're going to look at Hapoleum and how they used Chef. So Hapoleum is a bank, and it's the largest bank in Israel. And they have a mixture of Linux and Windows servers that they have to maintain. And as you can imagine, this requires a lot of constant configuration and work, and this has led to issues in the past. So the challenge that the team at Hapoleum faced was creating and hardening software that ran the major tasks and was repeatable on those servers, that it didn't matter who the people were performing the jobs, that there was consistency in the work that was being done, and address the problem that the servers, including the hardware on the servers, was not consistent throughout the organization. Chef addresses those specific problems and became the go-to product for Hapoleum. They were able to write the recipes and the cookbooks that could be deployed out to the network effectively, and it didn't matter what the system was. The recipes reflected the standards that the system administration team put together, and they were able to ensure and test each script and use standard testing tools for those scripts. It didn't matter what kind of environment that Hapoleum had, if certain ports need to be closed, or if a firewall needs to be installed or modified, or if custom strong passwords had to be created. All of this could be done using the recipes that Chef offers. And once those recipes had been finalized, they could be packaged into a common cookbook that could then be deployed to the entire network, ensuring a consistency in results for the company. And also, it didn't matter whether the cookbooks were being deployed to Linux or Windows machine, because the scripts were being put together in the recipes and were written in Ruby. You could actually go through and update and modify those scripts depending on the environment. So if you needed to make a modification for Linux, you could make those modifications so they were consistent across all the Linux servers or all the Windows servers. And this really drove in the ability to harden and secure the environment in the entire network within a matter of minutes using Chef versus the days and weeks that it previously took. So if we take a before and after scenario using Chef, before Chef, tasks were repeated multiple times and it was just hard to keep track of all the people doing the work. And the reality is, because so many people were touching all the different systems, specific standards that the banks had established were simply not being met. After Chef, all of the tasks could be scripted using Ruby, and using the recipe and cookbook model that Chef has created, the Chef tool was able to deploy out to the entire network specific cookbooks that provided a consistent experience and consistent setup and operation environment for all the hardware. The end result is that the system administration team could guarantee that the standards of the bank were being met consistently.
We're going to focus specifically on Puppet. So in this session, what we're going to do is we're going to cover what and why you would use Puppet. What are the different elements and components of Puppet and how does it actually work? And then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifest templates and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifest, templates, and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client that is used and communicated back to through the agent. So let's step through the workings of Puppet. So the Puppet environment is a master-slave architecture. The clients themselves are distributed across your network and they are constantly communicating back to a master server environment where you have your Puppet modules. The client agent sends a certificate with the ID of that server back to the master. And then the master will then sign that certificate and send it back to the client. And this authentication allows for a secure and verifiable communication between client and master. The factor then collects the state of the client and sends that to the master. Based on the facts sent back, the master then compiles manifests into the catalogs, and those catalogs are sent back to the clients, and an agent on the client will then initiate the catalog. A report is generated by the client that describes any changes that have been made and sends that back to the master, with the goal here of ensuring that the master has full understanding of the hardware running software in your network. This process is repeated at regular intervals, ensuring all client systems are up to date. So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are: 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
So first we'll see the career with Cloud Associate Cloud Engineer. Leave the server racks behind and venture into the dynamic world of cloud computing. The perfect moment has arrived. And now let's talk about what this certification means for you. Your Associate Cloud Engineer certification is like a beacon, signaling to prospective employers your prowess in Google Cloud. As an Associate Cloud Engineer, you will be adept at deploying and securing applications and infrastructure. You will maintain enterprise solutions to meet performance standards and keep a watchful eye on the operations of multiple cloud projects. But that's not all. Associate Cloud Engineers also prove their mastery in using the Google Cloud Console and command line interface. You will effortlessly manage and scale cloud solutions, leveraging Google managed or self-managed services on Google Cloud. And many of our peers once dwelled in the on-premises realm, meticulously setting up servers. Now they are prepared to level up their skills for the cloud era. The Associate Cloud Engineer certification is your stepping stone to a flourishing IT career. So picture yourself as a cloud developer, architect, security engineer, systems engineer, or network engineer. The possibilities are endless. So let's get started with the benefits of doing GCP ACE. So the first benefit you can gain by acing this certification is you will have the membership to Google Credential Holder Portal. So I will show you. So this is the Google Cloud Certified Directory. Here you can find all the people who have cleared this certification, and you can just click on their LinkedIn profile and see what skills they possess. And you have other filters also, that is you can search by the credentials, locations, or skills. So this is the first benefit of doing GCP ACE. Now moving back, the second benefit is exposure to all GCP services while preparation will boost your confidence. And then this will set a good foundation for professional architect exam and Google certification and badge to be used in your profile for visibility. That will uphold your profile and will gain you many opportunities. And now we'll see steps what you can follow to ace the GCP ACE certification exam. So before we dive in, it's essential to grasp the exam structure. The Google Associate Cloud Engineer certification exam consists of 50 multiple choice questions, and you have a total of 2 hours to complete it. A passing score requires at least 70% correctness. This exam evaluates your knowledge of Google Cloud Platform services, basic networking concepts, and cloud computing fundamentals. And the recommended experience for this certification is 6+ months. And the prerequisites are none for this certification exam. And the link to register for this exam, I will mention that link in the description box below, and I will show you the link also. So this is the link here you have to go and make your profile if you don't have an account, and after that you can log in. So this is here where you will register for the exam. And moving back, now we'll see the step 2, that is getting familiar with GCP. So to succeed, you need to become best friends with Google Cloud Platform. Luckily, Google offers a free tier that allows you to explore GCP's product and services without cost. And don't forget about the comprehensive GCP documentation. It's your treasure trove of insights into various services and functionalities. So you can just go to the documentation and read it. And the third is enroll in a course or training program. So education is the key here. Enroll in a course or training program tailored to the Google Associate Cloud Engineer exam. The Simplilearn Caltech Cloud Computing Bootcamp course lets you master key architectural principles and develop the skills needed to become a cloud expert, and provides in-depth coverage of exam topics. Or if you prefer hands-on experience, the Associate Cloud Engineer Exam Prep Quest from Quick Labs is a great choice. And I will mention the link for the bootcamp in the description box. You can go there and you can enroll in a course or training program to ace the preparation. And now the step 4. Take practice test. Sharpen your skills with practice test. Google Cloud offers official practice test for purchase which give you a real feel for the exam environment. Cloud Guru and Wiz Labs also provide valuable practice exams. And if you are budget conscious, Exam Labs offer free practice test. And now moving on to the step 5. Review exam objectives and resources. So stay focused by reviewing the exam objectives outlined by Google Cloud. These guides serve as your roadmap to success. Dive deep into Google Cloud's documentation and white papers for additional study materials. Don't forget to engage with the Google Cloud community on Reddit for valuable insights and tips. And now talking about the syllabus, I will move to the website directly only. So this is the syllabus for Google Cloud Architect. So here you will learn and you should know the setting up a cloud solution environment for setting up organization resources. That is, then you should have a knowledge on planning and configuring a cloud solution, deploying and implementing a cloud solution, and ensuring successful operation of a cloud solution. So these all are the things that are covered in the syllabus. So you should have a hands on that. As I told you about the bootcamp, so all these syllabus topics are covered in that bootcamp or the postgraduate program that I mentioned in the starting. So if you want to ace the program, you can just enroll in the course or training program. And now moving back, now we'll just have a look at the tips to ace this exam. So the first tip is book the exam in advance before starting preparation so you don't miss out. And the second tip is practice, practice and practice. That will help you clear that certification. And the third tip is start the exam with a relaxed mind and take pauses after 5 questions each time. That really helps. And then we have the fourth tip, that is understand intention of question, look for keywords in questions and answers. And the tip 5, while choosing options, focus on available option. Do not worry about perfect answer. And there you have it, Tech Explorers, your gateway to a cloud-powered future awaits. The Cloud Engineer Learning Path, crowned by the revamped Preparing for the Associate Cloud Engineer Certification course, is your compass to steer your career toward new horizons.
Certifications are the passport to a successful career in the ever-evolving world of technology. They validate your expertise in essential DevOps practices, tools, and principles. These certifications not only boost your credibility but also open doors to lucrative job opportunities, with salaries reaching up to $108,000 per year in the United States. In this video, we will be discussing top 4 DevOps certifications that you must enroll if you actually want to gain knowledge and make a successful career in the DevOps field. The topics that we will be covering are: first, why DevOps, then skills of DevOps professionals, and then the top certifications for DevOps. Stay tuned till the end of this video if you want to have a look at those certifications. Also, before we begin, make sure to subscribe to our YouTube channel and press the bell icon to never miss an update from Simplilearn. Now let's start with the first topic, which is why DevOps. So in 2024, DevOps is more important than ever because it helps teams work together smoothly, making software development and IT operations faster and more efficient. Think of it as teamwork for technology. With the world relying on digital services, we need to deliver software quickly and reliably. DevOps make this happen by bringing development and IT operation closer. They communicate better, share ideas, and use tools to automate tasks. This means fewer errors, faster fixes, and happier customers. Learning DevOps in 2024 is necessary because it offers numerous benefits in the rapidly evolving tech landscape. Firstly, DevOps practices enable organizations to deliver software faster, ensuring they stay competitive in the market. Secondly, DevOps fosters collaboration and communication between development and operation teams, leading to improved efficiency and reduced errors. Thirdly, automation plays a crucial role in DevOps, allowing teams to streamline process and focus on innovation. Fourth, DevOps skills are highly sought after by employers, providing excellent career opportunities. Alright, so this was about why DevOps. Now let's have a look at the skills of DevOps professional. So being a DevOps professional requires a diverse set of technical skills to bridge the gap between development and operations. Here are some of the skills of DevOps professional. First, containerization. Mastery of containerization technologies such as Docker is essential. Containers make it easy to package and deploy applications consistently across different environments. Next is orchestration tools. Proficiency in container orchestration tools like Kubernetes is important. These tools manage the deployment, scaling, and maintenance of containerized applications. Next is scripting and coding skills. Proficiency in scripting languages like Python, Ruby, or Shell scripting is crucial. DevOps professionals often write scripts to automate tasks and processes. Version control. Understanding and using version control systems like Git is essential. It helps track changes in code and collaborate effectively with team members. Next is continuous integration and continuous deployment, that is CI/CD. Knowledge of CI/CD tools like Jenkins, Travis CI, or Circle CI is key. These tools automate buildings, testing, and deploying software, ensuring rapid and reliable releases. Next is cloud platforms. Expertise in cloud platforms like AWS, Azure, or Google Cloud is essential for scalable and flexible infrastructure management. So this was about the skills of a DevOps professional. Now let's discuss the certifications, that is the top certifications. So the first certification on the list is Professional Certificate Program in Cloud Computing and DevOps. The Professional Certificate Program in Cloud Computing and DevOps offered by Simplilearn is an exciting opportunity for anyone looking to gain valuable skills and tools in the world of cloud computing and DevOps. This course is in partnership with E&ICT Academy, IIT Guwahati. This comprehensive program covers a wide range of technical skills and tools that are in high demand in the IT industry. It combines the power of cloud computing with efficiency of DevOps to create a well-rounded skill set. In this course, you will learn about cloud platforms like AWS and Azure, which are the backbone of modern IT infrastructure. You will discover how to deploy and manage applications on these platforms, ensuring scalability and cost efficiency. This is akin to mastering the tools that architects use to construct sturdy and adaptable buildings. The DevOps component of the program equips you with essential skills such as continuous integration and continuous deployment, CI/CD, automation, containerization with Docker, and configuration management with tools like Ansible. It's like having a toolkit that streamlines the software development and deployment process, making it faster and more reliable. By completing this program, you will be well prepared to excel in roles where cloud computing and DevOps expertise are essential. It's a pathway to a promising career and a chance to become a proficient in the skills and tools that are shaping the future of the IT industry. Alright, so this was about Professional Certificate Program in Cloud Computing and DevOps. Now coming to the next one, that is DevOps Engineer Masters Program. So introducing our DevOps Engineer Training Masters Program, your gateway into a thriving career in DevOps technologies. This comprehensive course equips you with the technical skills and tools essential for deploying, managing, and monitoring cloud applications. In this DevOps Engineer course, you will delve into the deployment methodologies, CI/CD pipelines, all while mastering a robust arsenal of DevOps tools such as Git, Docker, Jenkins, and more. Think of it as a toolbox packed with the latest, most powerful equipment for your tech journey. Our program offers 120 plus live classes, instructor-led online classes, ensuring you learn directly from the industry experts. Additionally, you will gain access to 90 plus hours of high-quality e-learning, real-life case studies, chapter-end quizzes, and simulation exams, making your learning experience rich and hands-on. But it doesn't stop there. You'll also become a part of a vibrant community moderated by DevOps experts, where you can share insights and grow together. So if you are ready to embark on a career in DevOps, do enroll for this program. So this was about DevOps Engineers Master's Program, postgraduate program in DevOps. Now let's move on and have a look at the next certification of DevOps, that is Azure DevOps Solutions Expert. Embark on a transformative journey towards becoming an industry-ready professional with the Azure DevOps Solutions Expert Master's Program. This comprehensive course is your gateway to a flourishing career in the dynamic cloud and DevOps industry. In this program, or in this certification, you will master the art of working smarter, collaborating efficiently, and delivering faster results using the cutting-edge array of modern development services. You will be armed with the knowledge and skills that employers in the industry truly value. What sets this program apart is the industry-recognized certification you will earn upon successful completion, a testament to your expertise. So, for all the courses that we have now discussed, you will get a certification for that. Alright, now what makes this learning experience exceptional is the opportunity to learn from leading industry experts who have created the course content to ensure it directly applicability in the real world. You will not only gain knowledge but also work on the practical projects backed by our network of industry partners and their career services. Job assistance services, personalized CV building, career affairs, and interview preparation make your transition into roles like Azure Pipeline, Azure Container, Azure Storage smoother. Whether you're a fresh graduate eager to make your mark or a professional looking to pivot into the exciting field of cloud security, this program opened doors to a world of possibilities in the cloud and DevOps landscape. So this was about the Azure DevOps Solutions Expert. As you explore the vast landscape of DevOps and cloud computing certifications, remember that your journey towards expertise is a professional one. Each certifications like IIT Guwahati Professional Certificate in Cloud Computing and DevOps, DevOps Engineer Master's Program, Postgraduate Program in DevOps, and Azure DevOps Solution Expert offers a unique path to owning your skills. Whichever you choose, know that your commitment to learning and growth will open doors to a world of opportunities in this exciting and evolving field.
Industry. So in this explanation of the top 10 DevOps projects, we'll delve into the innovative solutions and tools that are catalyzing progress from automation and containerization to continuous integration and deployment. These projects not only facilitate agility but also drive excellence in software delivery, ensuring that DevOps remains at the forefront of modern technology. So join us as we embark on a journey through the most influential DevOps initiatives of our time. With that said, if these are the types of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified. And if you're a professional with minimum 1 year of experience and an aspiring DevOps engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no. Simplilearn's postgraduate program in DevOps from Caltech University in collaboration with the IBM should be your right choice. For more details, use the link mentioned in the description box below. So let's start with why are DevOps skills crucial. Understanding DevOps is vital for optimizing the software development lifecycle. DevOps engineers need to master several key skills. Linux proficiency. Many firms prefer Linux for hosting apps and managing configuration systems. It's essential for DevOps engineers to be well versed in Linux as it's the foundation of tools like Chef, Ansible, and Puppet. Continuous integration and continuous delivery. CI ensures teams collaborate using a single version control system, while CD automates design, testing, and release, improving efficiency and reducing errors. Number 3. Infrastructure as code. Automation scripts provide swift access to necessary infrastructure, a critical aspect with containerization and cloud technologies. IAC manages configuration, executes commands, and swiftly deploys application infrastructure. Configuration management. Tracking software and operating system configurations ensures consistency across servers. Tools like Ansible, Chef, and Puppet simplify this process, making it efficient. At number 5, we have automation. DevOps aims for minimal human intervention, maximizing efficiency. Familiarity with automation tools like Gradle, Git, Jenkins, and Docker is essential for DevOps engineers. So these tools streamline development processes and enhance productivity. Moving on to the first project of the day, we have unlocking efficiency of Java application with Gradle. Meet Gradle, the versatile build automation tool transcending platforms and languages. This project helps you start on a journey of Java application creation, breaking it into modular subprojects and more.
The main aim of this project is to help you master project initiation as a Java application, adeptly build it and generate meticulous test reports. You will be well versed in running Java applications, crafting archives, and elevating your Java development prose. So dive in to transform your coding skills with Gradle. The source code for this project is linked in the description box below. Moving on to project number 2, unlock robust applications with Docker for web servers. Docker, the go-to container technology, revolutionizes services and app hosting by virtualizing operating systems and crafting nimble containers. This project focuses on creating a universal base image and helping you collaborate with fellow developers in diverse production landscapes. You will be dealing with taking web apps foundations in Python, Ruby, and Meteor. So master this project and you will yield Docker file efficiency like a pro, slashing build times and simplifying setups. So say goodbye to lengthy Docker file creation and resource-heavy downloads. The source code for this project is also mentioned in the description box below, so don't forget to check out. Moving on to project number 3, we have master CI/CD pipelines using Azure. In this Azure project, we harness Azure DevOps to create efficient CI/CD pipelines. This project mainly focuses on leveraging Azure DevOps project. We deploy applications seamlessly across Azure services like App Service, virtual machines, and Azure Kubernetes Service or AKS. Utilizing Azure's DevOps Starter, we set up ASP.NET sample code, explore pre-configured CI/CD pipelines, commit code changes, and initiate CI/CD workflows. Additionally, we fine-tune monitoring with Azure Application Insights for enhanced performance insights. The source code for this project is also mentioned in the description box below. Moving on to the next project, elevating Jenkins communication, the remoting project. The Jenkins remoting project is all about enhancing Jenkins communication capabilities. It's an endeavor to bolster the Jenkins remoting library, creating a robust communication layer. This project incorporates a spectrum of features from TCP protocols to efficient data streaming and procedure calls. As a part of this project, you will start on the exciting journey of making Jenkins remoting compatible with bus technologies like ActiveMQ and RabbitMQ. To succeed in this project, a strong grasp of networking fundamentals, Java, and message queues is your arsenal. Dive in and join us in elevating the way Jenkins communicates with the world. Check out the link mentioned in the description box below for the source code. Moving on to project number 5, automated web application deployment with AWS, your CD pipeline project. In this project, you will create a seamless continuous delivery pipeline for a compact web application. Your journey begins with the source code management through a version control system. Next, discover the art of configuring a CD pipeline enabling automatic web application deployment whenever your source code undergoes changes. Embracing the power of GitHub, AWS Elastic Beanstalk, AWS Code Build, and AWS Code Pipeline. This project is your gateway to streamlined, efficient software delivery. The source code for this project is linked in the description box below. Moving on to the next project, containerized web app deployment on GKE, scaling with Docker. This project will help you discover the power of containerization with this project. You will learn how to package a web application as a Docker container image and deploy it on a Google Kubernetes engine or GKE cluster. You can watch your app scale effortlessly to meet user demands. These hands-on projects cover packaging your web app into a Docker image, uploading it to artifact registry, creating a GKE cluster, managing auto-scaling, exposing your app to the world, and seamlessly deploying newer versions. You get to unlock the world of efficient, scalable web app deployment on GKE. The source code for this project is linked in the description box below. Moving on to project number 7, mastering version control with Git. In a world of software development, mastering a version control system is paramount. Version controlling enables you for code tracking, version comparison, seamless switching between versions, and collaborating among developers. Your journey in this project will begin with the fundamental art of saving code in a VCS, taking the scenic route to set up a repository. You can then start on a quest through code history, unraveling the mysteries of version navigation. Navigating through branching, a deceptively intricate task, is next on your path. By the end of this project, you will be fully equipped to conquer Git, one of the most powerful version control system tools in the developer's arsenal. The source code for this project is mentioned in the description box below. Moving on to the next project, effortless deployment, running applications with Kubernetes. The major focus of this project is to help you harness a straightforward web service that handles user messages, akin to a voicemail system for leaving messages. Your mission, you ask. You get to deploy this application seamlessly with Kubernetes, then Dockerize it. By mastering this fundamental step, you will unlock the power to run your application in Docker containers, simplifying the deployment process. The source code for this project is mentioned in the description box below, so don't forget to check it out. Moving on to the project number 9, Mastering Terraform Project Structure. This project will help you maintain and extend the efficiency of Terraform projects in everyday operations. A well-structured approach is essential. This project unveils the art of organizing Terraform projects based on their purpose and complexity. So harness the power of key Terraform features, including variables, data sources, provisioners, and locals, to craft a streamlined project structure. By the end, your project will effortlessly deploy an Ubuntu 20.04 server on DigitalOcean. Configure an Apache web server and seamlessly point your domain to it. Level up your Terraform game with proper project structuring and practical application. Check out the link mentioned in the description box below for the source code. Moving on to the last project of the day, we have efficient Selenium project development and execution. In the world of test automation, Selenium projects play a pivotal role. They enable seamless test execution, report analysis, and bug reporting. This proficiency not only accelerates product delivery but also elevates client satisfaction. By the end of this project, you will master the art of building Selenium projects, whether through a Java project or a Maven project, showcasing your ability to deliver high-quality results efficiently. Check out the link mentioned in the description box below for the source code to this project.
Understand what is DevOps? DevOps is like a teamwork approach for making computer programs better and faster. It combines the work of software developers and the operation team. The goal is to help them work together and use tools that speed up the process and make fewer mistakes. They also keep an eye on the programs and fix problems early. This way, businesses can release programs faster, with few errors, and everyone works better together. If you want to learn more about this, then check Postgraduate Program in DevOps to understand from the basics to advanced concepts. This postgraduate program in DevOps is crafted in partnership with Caltech CTME. This comprehensive course aligns your expertise with industry benchmarks. Experience our innovative blended learning, merging live online DevOps certification sessions with immersive labs for practical mastery. Advance your career with hands-on training that meets industry demands. Alright, now let's move on to the first question of DevOps interview question, which is, what do you know about DevOps? So think of a DevOps like teamwork in the IT world. It's become really important because it helps teams work together smoothly to make computer programs faster and with fewer mistakes. Imagine a soccer team. Everyone works together to win the game. DevOps is similar. It's when computer developers and operations people team up to make software better. They start working together from the beginning, when they plan what the software will be like, until they finish and put it out for people to use. This teamwork makes sure things go well and the software works great. So this was about DevOps. Now moving on to the second question, which is, how is DevOps different from agile methodology? DevOps is like a teamwork culture where the people who create the software and the people who make it work smoothly join forces. This helps in always improving and updating the software without any big breaks. Agile is a way of making softwares that's like taking small steps towards instead of big jumps. It's about releasing small parts of the software quickly and getting feedback from the users. This helps in solving any issues or differences between what users want and what developers are making. So you can answer this question in this way. Alright, moving on to the third question, which is, what are the ways in which a build can be scheduled/run in Jenkins? So as you can see, there are 4 ways: by source code management commits. Second is after the completion of other builds. Third is scheduled to run at a specified time. And fourth one is manual build requests. So if the interviewer asks, then you can answer these 4 ways in which a build can be scheduled in Jenkins. Alright, now the fourth question is, what are the different phases in DevOps? So the various phases of DevOps lifecycle are as follows. So as you can see, first is plan. So initially there should be a plan for the type of application that needs to be developed. Getting a rough picture of the development process is always a good idea. Then code. The application is coded as per the end user requirements. Then there is build. Build the application by integrating various codes formed in previous steps. After that, there is test. This is the most crucial step of the application development. Test the application and rebuild if necessary. Then there is integrate. So multiple codes from different programmers are integrated into one. After integrate, there is deploy. So code is deployed into a cloud environment for further usage. It is ensured that any new changes do not affect the functioning of a high traffic website. After that, there is operate. So operations are performed on the code if required. Then there is monitor. Application's performance is monitored. Changes are made to meet the end user requirements. So these all were the different phases of DevOps. And here we have explained each one of these. You can go through it, and if the interviewer have asked you this question, you can answer it in a similar way. Alright, now moving on to the next question, which is mention some of the core benefits of DevOps. So the core benefits of DevOps are as follows. First of all, we'll say technical benefits. First, technical benefit of DevOps is continuous software delivery. Then second is less complex problems to manage. Third is early detection and faster correction of defects. Then here comes the business benefits. The first benefit of DevOps, that is business benefit of DevOps, is faster delivery of features. So it allows faster delivery of features. Then there is stable operation environment. Then third one is improved communication and collaboration between the teams. So these were the business benefits. So here we have discussed both technical benefits and business benefits. Alright, now the next question is, how will you approach a project that needs to implement DevOps? So here are the simpler terms. Here's how we can bring DevOps into a specific project using these steps. Step 1 would be, first, we look at how things are currently done and figure out where we can make them better. This makes about 2 to 3 weeks. Then we can plan for what changes to make. Then step 2 would be, we create a small test to show that our plan works. When everyone agrees with it, we can start making the real changes and put the plan into action. Then third step would be, we are all set to actually use DevOps. We do things like keeping track of different versions of our work, putting everything together, testing it, and making it available to the users. We also watch how it's working to make sure everything goes smoothly. By doing these steps right, the keeping track of changes, putting everything together, testing, and watching how it's going, we are all set to use DevOps in our project. So this is how you can approach a project that needs to implement in DevOps. And this is how you can answer this question. Alright, moving on to the question number 7, which is, what is the difference between continuous delivery and continuous deployment? Alright, so first would be continuous delivery. So it ensures code can be safely deployed on production, whereas continuous deployment, here every change that passes the automated test is deployed to production automatically. Then in continuous delivery, it ensures business applications and services functions as expected, whereas in continuous deployment, it makes software development and the release process faster and more robust. In continuous delivery, delivers every change to a production-like environment through rigorous and automated testing. Whereas in continuous deployment, there is no explicit approval from a developer and requires a developed culture of monitoring. So these were the 3 points that you can highlight while differentiating between continuous delivery and continuous deployment. Alright, so this was the question number 7. Now moving on to the question number 8, which is name 3 security mechanisms of Jenkins uses to authenticate users. So here we have to name 3 security mechanisms. First one would be, Jenkins uses an internal database to store user data and credentials. Second is, Jenkins can use the lightweight directory access protocol, that is LDAP server, to authenticate users. Third one is, Jenkins can be configured to employ the authentication mechanism that the deployed application server uses. So these were the 3 mechanisms that Jenkins uses to authenticate users. Alright, now moving on to the question number 9, which is, how does continuous monitoring help you maintain the entire architecture of the system? So continuous monitoring within DevOps involves the ongoing identification, detection, and reporting of any anomalies or security risk across the entire system infrastructure. It guarantees the proper functioning of services, applications, and resources on servers. By overseeing server statuses, it accesses the accuracy of application operations. This practice also facilitates uninterrupted audits, transaction scrutiny, and regulated surveillance. So this was about the question number 9, that was how does continuous monitoring help you maintain the entire architecture of the system. Now moving on to the question number 10, which is what is the role of AWS in DevOps? So in the realm of DevOps, AWS assumes several rules. First one would be adaptable services. So it offers adaptable pre-configured services, eliminating the necessity for software installation or configuration. Second one is designed for expansion. Whether managing one instance or expanding to 1,000, AWS services accommodate seamless scalability. Then there is automated operations. AWS empowers task and process automation, freeing up valuable time for inventive pursuits. The next one is enhanced security. AWS Identity and Access Management, that is IAM, allows precise user permissions and policy establishment. Then the last one is extensive partner network. So AWS fosters a vast partner network that integrates with and enhances its service offerings. So these were the role of AWS in the realm of DevOps. Alright, now moving on to the question number 11. Name 3 important DevOps KPIs. The 3 important KPIs are as follows. First one is mean time to failure recovery. This is the average time taken to recover from a failure. Second KPI is deployment frequency. The frequency in which the deployment occurs is called deployment frequency. Third one is percentage of failed deployments. The number of times the deployment fails is called percentage of failed deployments. So these were the 3 important DevOps KPIs. This question can also be asked. Alright, moving on to question number 12, which is how is IAC implemented using AWS? So commence by discussing traditional methods involving scripting commands into files, followed by testing in isolated environments prior to deployment. Notice how this practice is giving way to infrastructure as code IAC. Comparable to code for various services, IAC aided by AWS empowers developers to craft accesses and manage infrastructure components descriptively utilizing formats like JSON or YAML. This fosters streamlined development and expeditious implementation of alterations in infrastructure. Alright, now moving on to question number 13, which is describe the branching strategies you have used. They'll ask you this question. So to test our knowledge, the purpose of branching and our experience of branching at a past job, this question is usually asked. So here we will discuss topics that can help you answering this DevOps interview question. So release branching. We can clone the develop branch to create a release branch once it has enough functionality for a release. This branch kicks off the next release cycle, thus no new features can be contributed beyond this point. The things that can be contributed are documentation generation, bug fixing, and other release related tasks. The release is merged into master and given a version number once it is ready to ship. It should also be merged back into the development branch, which may have evolved since the initial release. So this was the first one. Then there is feature branching. This branching model maintains all modifications for a specific feature contained within a branch. The branch gets merged into master once the feature has been completely tested and approved by using tests that are automated. Then the third branching is task branching. In this branching model, every task is implemented in its respective branch. The task key is mentioned in the branch name. We need to simply look at the task key in the branch name to discover which code implements which tasks. So these were the branching strategies that you can say that you have used, or if you have really used it, otherwise you can say something else. Alright, moving on to question number 14, which is can you explain the shift left to reduce failure concept in DevOps? So shifting left within the DevOps framework is a concept aimed to enhance security, performance, and related aspects. To illustrate, consider the entity of DevOps processes. Currently, security evaluations occur before the deployment stage. By employing the left shift approach, we can introduce security measures during the earlier development phase, denoted as the left. This integration spans multiple phases encompassing pre-development and testing, not confined to development alone. This holistic integration is likely to elevate security measures by identifying vulnerabilities at initial stage, leading to a more fortified overall process. Now moving on to the question number 15, which is what is blue/green deployment pattern? So this approach involves seamless deployment aimed at minimizing downtime. It entails shifting traffic from one instance to another, requiring the replacement of outdated code and a new version to integrate fresh code. The updated version resides in a green environment while the older one remains in a blue environment. After modifying the existing version, a new instance is generated from the old one to execute the updated instance, ensuring a smoother transition. So the main focus of this approach is smooth deployment. Alright, so this was question number 15. Now moving on to the question number 16, which is what is continuous testing? So continuous testing involves the automated execution of tests within the software delivery pipeline, offering immediate insights into potential business risks within the latest release. By seamlessly integrating testing into every stage of the software delivery lifecycle. I repeat, by seamlessly integrating testing into the every stage of software delivery lifecycle, continuous testing minimizes issues during transition phases and empowers development teams and instant feedback. This approach accelerates developer efficiency by obtaining the need to rerun all tests after each update and project rebuild, culminating in notable gains in speed and productivity. So this was about continuous testing. Now moving on to question number 17. What are the benefits of automation testing? So some of the benefits of automation testing includes: first, it helps to save money and time. Second is unattended execution can be easily done. Third one is huge test matrices can be easily tested. The next one is parallel execution is enabled. Then there is reduced human generated errors which results in improved accuracy. And last one is repeated test tasks execution is supported. So these are the benefits of automation testing. Coming to question number 18, which is what is a Docker file used for? So a Docker file is used for creating Docker images using the build command. With a Docker image, any user can run the code to create Docker containers. Once Docker image is built, it's uploaded in Docker registry. From the Docker registry, users can get the Docker image and build new containers whenever they want. So this is what Docker file is used for. Coming to question number 19, which is what is the process for reverting a commit that has already been pushed and made public? So there are two ways to do that, to revert a commit. So first would be remove or fix the bad file in a new commit and push it to the remote repository. Then commit it to the remote repository using git commit -m commit message. Again, git commit -m commit message. So this is the first way. Then second is create a new commit that undoes all the changes that were made in the bad commit. Then use the command git revert commit id. As you can see in the screen, first command also and the second command also. The second command says git revert commit id. Commit id, you will have to put the commit id. Alright, so question number 19 this was. Now moving on to the last question, which is question number 20. How do you find a list of files that have been changed in a particular commit? So the answer would be the command to get a list of files that have been changed in a particular commit is git diff tree -r. Then there is commit hash. So this command, as you can see on the screen, git diff tree -r commit hash, you can put it. Then example is also there, like commit hash 87E6735F21B. So this is an example as you can see on the screen. Then there is -r flag instruct, so the command to list individual files, and commit hash will list all the files that were changed to or added in that commit. So there's telling about the, as you can see, -r functionality. -r is a flag that instructs the command to list individual files, and commit hash will list all the files that were changed or added in that commit. So these were the top 20 DevOps interview questions that you must understand if you're planning to give a DevOps interview. So in this video, we have explored key concepts, methodologies, and best practices that are crucial in fostering collaboration between development and operations teams. By understanding the principles discussed here, you are well equipped to navigate the dynamic landscape of DevOps and drive successful software delivery. As we wrap up this DevOps full course for 2024, we hope you have gained valuable insights and skills to thrive in today's tech landscape. You have found this content helpful. Don't forget to like, share and subscribe for more enriching tech tutorials. Your feedback is crucial, so drop your thoughts in the comment section below. Stay connected for the latest updates and remember, the future of tech starts with continuous learning. Thanks for joining us on this journey and we look forward to seeing you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.